All right, we're back with more Rust today. Let's get right back on it while people hopefully gather. No more starting soon. Chuk, chuk, chuk. Nah, this looks pretty good. Like the zoom level, yes, more, bigger. No, this is pretty good. Lower is fine. Kind of don't like where the line is. All right. All right, we're back with Rust. Now, once again, it's been a week-long break. Not the best for learning, because it seems like we left off at hash maps. I do remember having trouble with the syntax here. Oh yeah, let's take a look at what we did here. So we talked about insert. Let me read the hash maps again. And actually, let's read the Rust book. So we got the Rust book. We got the vanilla Rust book and the CS Brown Rust. Obviously, the good old playground. Yup, we're gonna need the playground for sure. And I think that's all. We had the Rust docs, of course. So, for example, hash map Rust. I think this is the setup, right? The Rust book. Okay, let's see how much I remember about hash maps. Damn. Key value, that's pretty much it. Chuka. Use standard collections. Hash map. Scores. Insert. Key value. Okay, so this is not type annotated. I don't even remember how to type annotate this. Damn, the syntax is still killing me. Maybe it's time we need to start programming. We are getting into the middle sections though, which is really good. But the syntax is still killing me, to be honest. And I'm not quite sure what to do about that. I guess we'll have to keep reading the book. So, creating a new accessing values string from, team name, get, insert and get. This is get a reference. So we get reference. Okay, so get always gets a reference. Well, it gets an option to a reference. And then copied runs a copy to get us the option on a type, and then unwrap or is an option thing. Okay, pretty clear. So by calling copy to get an option of type rather than an option of reference, I guess because we can call copied on I32 because it implements it. Unwrap or to set score. Okay, we can iterate over for key value, print key value, scores, Pythonic. Oh boy. I feel the map insert. For types that implement copy, for owned values, the values will be moved. Okay, so it's basically always moved. Well, for types that implement copy, it's copied. For types that, like string, that own their data, the values will be moved and hash map will be the owner of those values. Both the key and the value. If we insert, instead, if we insert references to values, the values won't be moved, but the keys still will. I think I vaguely remember the same trick works on references to keys. Definitely we messed with that. Updating a hash map. Low number of key value pairs is growable. Each unique key can only have one value, blah, blah, blah. Overwriting a value. Insert. Okay. Nothing too fancy here. Adding a key and value only if a key isn't present. Aha. Now, where we had a lot of syntactical trouble remembering this entry. Or insert. Oh, I remember this. So, hash maps have a special API called entry that takes the key to check as a parameter. The return value is an enum called entry that represents a value that might is an enum called entry. So let's read this a bit because we did not read it. Maybe we did. What the heck is an entry? Is this? Yes, this is a core Rust type. It's in the standard library. Hey, thanks for joining. We're the first one here. I was just recapping the hash maps I did last time. Let's see. Yeah, so this entry, interesting. So this is an enum with occupied and vacant. I don't remember. I don't think we looked at this one. Or insert. And returns the mutable reference. Damn, we had so much syntactical trouble with this one last time. Map entry or insert. I guess internally it checks if it's occupied or vacant. Okay. Or insert with, insert by entering the result of the default. Oh, I see. This is a closure with the default value. Insert with key. Returns a reference to this entry's key. Interesting. Map entry. All right, so this is just a quick recap. We'll have to hope I remember all this. And that's it. That's what we did. We looked at hash maps, and then we did. So the book says error, generic, and traits. What does my stream title say? Generics and traits. Oh my god, it's gonna be a huge stream then. Yes. Let's get to what does the Rustlings say after hash maps? Options. Okay, let's do this one because I should know this one. The option type, yeah, we've seen this many times now. The option represents an optional value. Every option is either some and contains a value or none and does not. Option types are very common in Rust code. Initial values, return values, blah, blah, blah. So it's chapter 10 in the book. Oh man, it takes me all around the world. Let's see. Options, some, none. Well, I think for this one we can read the docs. Like I understand enough syntax now to read the docs here. Oh, and we've seen this many times. All right, let's. I think I can YOLO the quiz then. I should know this. This should be like a warm-up quiz. You would think so. You would really hope so. Rustlings. 11 hash maps. Next. Oh, there's a quiz. Okay. All right. There's a warm-up quiz in the middle, but these are really easy. Okay, good. Actually, this is the quiz for the following sections. Strings, vex, move, modules, enums. Oh my god. Okay, let's build a little machine in the form of a function. As input, we're going to give a list of string and commands. The vector, I guess. Holy shit, this is hard, actually. Wait, I have to write... These commands determine what action is going to be applied to the string. So I have to implement the transformer. The string. Now, what does it want in the API? String? Let's see. Oh, no. It's a vector of tuples. The input is going to be a vector of true length tuples. Yes. Oh boy. So how the heck do I type annotate a vector of the first element is the string, and they want an owned string? Yes, it's an owned string, not a reference. And the other one is the command. So it's an enum. And they want the output is going to be a vector of owned strings. Okay. This looks... It's the first time I have to type annotate a tuple though in a vec. Let's see if we can check the docs for this. This should be pretty straightforward. Vec in Rust. Vec T, so it's angled brackets. Okay, and then to annotate the tuple, it's regular parentheses, right? I think so. I've never type annotated a tuple, so this is new syntax. Interesting. Well, we'll have to believe it's this. Well, let's not believe it's this. Let's do the quick playground thing. I don't need this. Well, maybe I do need this, right? So I need, let's see, process. And I just want a vector tuple string and string, for example. Is this gonna compile? Print line hello. Yes, okay, so this is how you type annotate a tuple. Which makes sense, of course. It would have been ugly if it wasn't that. All right, we're gonna need the string docs for sure. String in Rust, because I forgot all the methods it has, of course. And let's get back to the exercise. So, what do we need to do with the input? Okay, I guess we can unpack it, right? So word command is no. Wait. Let. Yes, I think it's like this, right? Word command is input. Oh boy. I know we can do let word is input dot 0, let command input dot 1, which is ugly. Let's do what we know first, right? So this is a string and this is a command. I'm gonna have to match on the command probably. These commands determine what is going to be applied to the string. It can either be uppercase, trim, append bar, a specified number of times. I see. Okay, so let's match on command. Aha. Okay, so I think I know how to optimize this. So, but let's do the naive case first. So then if command is command uppercase, so we're gonna do let processed, which is also a string, be the evaluation of the expression match on command. If it's uppercase, I have to do word dot to upper, I think. Okay, so now we have to check the docs. What the heck does to upper do? Oh, to uppercase, it returns a new owned string, which is what we want. Okay, so it's to uppercase. Is it to upper too, or why did I say to upper and it's valid? Oh no, it's not. It's to uppercase. Okay, so then this is a new string, which is exactly what we want, because we want this to be a new string. So to uppercase, and that's it. Let processed. Okay. So we're gonna return an own string, and then I'll give back. Oh, wait a second. It's a vec though. Uh-oh. So we go for command in input. Let's call this inputs, and let's call for input in inputs. And we're gonna have to create let outputs is a vec of string, an empty vec. Okay. So then we're gonna push outputs dot push processed. And we're going to return outputs. This is obviously not Python, so for needs brackets, obviously. Okay, so then we can finish processing the other commands now. Oh my god, this is way harder than I expected though. Like, this is a full-blown exam now. And as usual, the syntax is killing me. Okay, so the other command is trim, which I believe is trim white space. Now the problem is we gotta read that one too. So trim. Uh-oh. Returns a string slice. Now we have a problem because we have to return a string. So what do? Do I do toString? I think so. But does it give me own data? Where the heck does it? Oh, here it is. Okay. Converts the value to a string. I guess it's the most vague document ever. So it's the trait toString. Yes, so it does give me an own string. All right, so then we know how to implement this one too now. So I trim and I do word.trim.toString. The other one is command append, and it has an integer padding, which I unpack here, if I remember the syntax correctly. Which is a big guess. The output element, so append bar to the string a oh my god. How do I repeat a for loop here? I guess everything is an expression in Rust, so I can do this. Let's see, this is how I would do it naively, right? So no, wait. Damn it. All right, so how do I, is there an append repeat? Okay, this is hard to do manually. I don't know what the goal is. Do they want me to do this manually, or what do I have to do? So append. Char to a string with push. Oh shit, it's push. So they want me to do push. Push. No, this is a char. Push str. Pushes a string to a string. Sorry, a string slice onto the end of this string. Okay, so I need to push bar And this is in place. So I need mutable then. Damn, I feel like my code is so not ergonomic. Like... So for I in 0 padding, word dot push str bar, and give me back the new word. That's it. And I pushed the vect. Let's see. There's no way I got this right? Like in one go. This would be pretty wild. Wait a second. What do we need to import to have transformer in scope? Aha, so it's testing the module. It's a bunch of bullshit here. So it's use something, definitely. What does it want me to do here? Super, where am I? Oh my god, I forgot where I am. Definitely super works, but I think there's a more elegant thing here. If I'm in a module, I'm already at the top level. So I can use my module, I think. Or is it super my module? Super is the safe one. I don't think it's needed though. We'll try some stuff. Super my module. Transformer. That's it. Not that great big of a deal. Could not compile. Oh, cannot find padding in this scope. Ah, because I cannot pass it in this scope. Obviously semicolon. Okay, append, obviously. Where semicolon? Line 47. Yes, let processed. Let mutable. Oh wow, it actually worked. Okay, so we got every. Oh my god. Okay, so pretty good warm up. All right, so we. Wow, this was actually a program we wrote. This is the first program I ever wrote in Rust. Like, from a spec in my life. When nobody is in chat to see it, which is pretty wild. Or maybe somebody's on YouTube. No. We have one person. Whoever you are on Twitch, congratulations. All right, pretty wild. So it's the 6th stream in the series. I can't believe this worked in the first shot though. Minus, of course, the syntax, because this is not Python. Now, let's try to optimize this because it looks horrendous. Like this is the least ergonomic Rust ever, right? So first, can I cut this super? I cannot cut the super. Damn it. Huh. Interesting. I guess not. Okay. Oh, it tells me I could have done crate, which is probably more ergonomic for both of these. Yes, I think I like this better. Maybe not. It's less portable though. Okay, so super is fine. Now, okay, this is a child's play. What the heck are we doing here though? Because this code looks horrendous. So, let's start with the basics. Can I unpack this in a single line? Can I unpack? So can I match? Aha, wait a second. Match input into word. No, but I need a mutable there though. No, 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 no. Let mute word command equals input. Is this more ergonomic? Definitely. Does it work? Oh, parentheses like a tuple. Okay. Good. Okay. So nicer Rust, clearer. Now the bigger question is, can I match directly on the pair? Can I unpack? I don't remember the match syntax, so let's figure out if we can figure it out by ourselves. We know how to match on a scalar. No, I don't want this. I want the... Well, okay, fine. We need the book. How do I match on a tuple? I forgot. But how do I... Can I simultaneously... Well... Okay, so there's a couple of questions I have here. So, what the heck? These are all scalar matches? Uh-oh. Really? Huh. Match on a tuple. No, 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 no. Tuples can be... This is what I want. Tuples can be destructured in a match. Aha, so I put concretes and variables. Damn it. I knew it. Okay. So, we don't need this at all because I can match on command and say that word command, so it's variable concrete, returns this. Word command trim returns this. Now the big one. Mutable word returns this. Is this valid Rust syntax? And I'm not matching on command, I'm matching on input. Oh my god, it is. So I can switch mutability. So this is exactly let. All right, so this is way more ergonomic code now. So I have a mutable vector. Okay, let's take a look at the outputs. What the heck is going on here? So I have a mutable vector of outputs, which are own strings. I don't think I can optimize that to be cleaner, right? This looks how a Rust programmer would write it. You would hope so, think so, possibly. Yes. All right, so pretty happy with this. So processed, now. Yeah, I think this is good enough. So match word to uppercase, it gives me, I need this because it gives me its own string. Trim on string gives me back a string slice, so I need to do two string. Don't know if I can elide this. And this is the tricky one. So I unpack a mutable word. Now, what the heck do we do with this for loop? And I unpack the padding. And I evaluate an expression. Let's add a test. What happens if I... let's see if I do 0. This should still work, right? If I append to dog bar 0 times, I should see a dog here. Yes, good. So it works as expected. If I append -1 times, that's not going to build because it's negative. Yes, good. Good, 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 good. Pretty happy to be with this, to be honest. So we unpack. Wow, I can't believe we wrote the first program ever in Rust that actually does something. Process string. If I were to be cheeky, I can also do Now this is gonna look horrendous, but I can push the whole match, can I not? I believe so. It looks as bad as one would expect. But I can directly push this expression because everything is an expression in Rust. So 4 input. Yep, there we go. So I can make this even more ergonomic. Now, of course, the compiler is going to optimize this. It doesn't matter, right? Yeah, is this more readable? Probably, definitely. Okay, so now if I do it this way, this brings me suspiciously close to what Python would call a map function, doesn't it? I don't know the syntax for it in Rust, but I bet you there's a way to create a vector just from a map function that processes the input. Yeah, so I would need the scalar version of this. Okay, so maybe to anticipate, so transformer, the little one is transform that takes as input just a tuple and gives you back an own string and does the whole thing. Okay. And that's it, and it returns it directly. Okay, so you get a string guaranteed. And then we're just pushing transform the input. This is definitely more readable now. Okay, now it's a closure here. Actually, it doesn't matter. Yeah, oh, okay, so then I can make it even cleaner. And maybe this doesn't have to be a closure, right? It can be an auxiliary function. Which I think... All right. It definitely looks... starting to look like real programmer code. I think. Because now it's a bit more functional, right? So this one is the vector version. This one is the inner version. Direct match on the input. Perfect unpacking. Uppercase, uppercase, string. Trim to string. This toString is annoying. So can I optimize the toString? Trim. Trim. Returns a string slice. Makes me wonder why. Let's try checking something out. I'm gonna get my hair tripped up on this, but why would a Rust programmer not give ownership back here? This must use. This returns the trim slice as a slice without modifying the original. Is there an in-place trim? Trim string in place. Does not provide, but you can efficiently trim trailing by using mystring.truncate. Truncate. Okay, so you just have to compose two methods. Ah, it looks uglier. Nah. Okay, so my question still stands. I wonder why, could I ever understand why the Rust standard library chose to return a string slice here and not an own string? Okay, so it just goes to trim matches. Okay, so let's see what trim matches does. So it's we're anticipating generics a bit. So it takes a type P, a pattern of P, and it returns a string slice with all prefixes and suffixes that match a pattern repeatedly removed. What does this do? So this is why. We need to understand why did the Rust people program this to not take ownership. Well, it takes a reference, so it doesn't take ownership, but why doesn't it return a new owned string? Because semantically, why would the Rust programmer make this return a string slice? Because you still... No, but so you don't take ownership of the string, so you never destroy it by calling this method. Because you want to avoid a copy, or you want to avoid allocating new data, and you're just returning indices. So you're just returning a slice from I to J, which references the same data on the heap. Do they not? Do slices? Yes, slices reference data on the heap in Rust. That does not own its underlying data. What did it say? The memory address can put you in contiguous. Okay. A slice is a dynamically sized type representing a view. Okay, so this is what Python also calls a view. Rather, we should say PyTorch. Because it's more efficient to take... Oh my god, so we're getting close to tensors here. It's more efficient to take views. Slice types are generally used for pointer types. A shared slice. A heap allocated array coerced to a slice. A shared slice into an array. All elements of slice are always initialized, and access to a slice is always bounce checked and safe method operators. Okay, so I think I know the answer. The answer is because this operation is contiguous. Because the output from this operation represents a substring, which means a continuous sub portion of the string, then you should always use slices. If you were to do, of course. When you do two uppercase, you cannot represent this as a slice. Okay, so perfect. So don't return own strings unless you know what you're doing or you have to do it. Sorry about that. That sounds pretty sane to me, to be honest. I'm pretty happy with this. What else is there to understand from here? The scary for loop. So I'm pretty happy with how I coded this though in the first try. So I unpack a mutable word. Well, let's see. Can I do this more efficient? I don't think... So I'm reallocating data on the heap every time. Well, I risk reallocating data on the heap every time I do push string. At the same time, I can't... There's no other way to do it without allocating new data. Is it more efficient to form the bar string repeated separately and then push it once? Because I could do push suffix. What does push return? Does it return the new owned string? That's a good question to familiarize ourselves. So string push. Oh, sorry, push string. Obviously, I would have to push a string. No, it does not return anything. So this is not gonna work. I'm gonna need a let. So it's push string, obviously. And I'll just do words. No, I don't need a let. And then I do what? Suffix string is string from empty, I guess. No, this seems wildly less efficient. I just wrote a monster. Whoa, what did I do here? So suffix. Oh, let. Mutable suffix. Oh yeah, so I can't even push. Right, so I ran into another snag here because push string pushes a string slice. Ugh, so I have to push the reference, which, yeah. Okay, well this looks wildly less efficient than what I had, which is like wild how I made it so bad, because you can just do this and this and this. Yeah, okay, we're definitely not allocating. Okay, this is easier because you it keeps appending to a contiguous region in on the heap. So yeah, this is pretty good. I don't know if we can make this better. What about the whole expression here? Is there another way to solve this? Probably not. Okay, I'm pretty happy with this. Very good exercise. Let's move on. Options. Not stock options, but options. Options we know. So let's read about options. In the Brown book. So we do some quizzes too. Where the heck are options in the Brown book? Chapter 10. Oh, okay. So it's 10.1. Okay, so I'm just going to read generics then. Forget about it, right? Let me just read generic. There we go, the big one. So the stream stays true to its title. All right, so let's read about generic types, traits, and lifetimes. This seems like the biggest chapter ever, by the way. Like, this is insane. Like, syntactically, this is probably going to be a huge graduation. All right, so yeah, we've seen options, vex, which we got right, hash maps, chapter 9 result. We have not seen errors yet. How to define your own types, but okay. So every programming language has tools for effectively handling the duplication of concepts. In Rust, one such tool is generics, abstract stand-ins for concrete types or other properties. We can express the behavior of generics or how they relate to other generics without knowing what will be in their place when compiling and running the code. Functions can take parameters of some generic type, okay, instead of a concrete type. Interesting. In the same way they take parameters with unknown values to run the same code on multiple concrete values. In fact, we already use generics. Yes, we know this. We'll review how to extract a function to reduce code duplication. We'll then use the same technique to make a generic function from two functions that differ only on the types. You know how to use traits to define behavior in a generic way. You can combine traits with generic types to constrain a generic type to accept only those types that have a particular behavior, so just any type. Finally, we'll discuss lifetimes. a variety of generics. They give compound information about how references relate to each other. Lifetimes allow us to give the... Oh my god, okay. Remove duplication by extracting a function. Generics allow us to replace specific types of placeholder. Represent multiple types. Okay, before diving into first I'll remove duplication. It doesn't. Okay. So for number, if number, largest number. Okay, so what the heck is the problem here? We stored the list. Oh shit, sorry. We store a list of integers in the variable number list and place a reference to first number in the list in a variable named largest. We then iterate to all numbers, and if the current number, we replace the reference in that variable. Yes. Oh, I see. Defining the largest number in two different lists of numbers. Is this like, are they introducing like the concept of functions? Because it's insane. Like, what the heck is going on here? Like, yeah, just move this to a function, right? Like copy pasting code. Okay, so we turn this into a function, obviously. To eliminate duplication, we'll create an abstraction by defining a function that operates on any list of integers. So this is a function with concrete types. All right, this is like basic programming, right? Okay. So the largest function has a parameter called list, which represents a concrete slice of i32 values when I pass it into a function. As a result, the function code runs on the specific values. Okay, so they're just explaining what the heck is a function. Sure, this is like super basic. All right, so generic data types. Generic data types. We use generics to create definitions for items like function signatures or structs, which we can then use with many different concrete data types. Function, structs, enums using generics. Then we'll discuss how generics affect code performance. When defining a function that uses generics, we place generics in the signature where we would usually specify the data types of the parameters and return value. So I write a slice of T then. Okay, so I have largest i32, largest char. Obviously the code has to be exactly identical for this to work, which I don't even know what the heck does that mean on chars. The largest char in a slice. The function, I guess it's ASCII or whatever. The function bodies have the same code, so let's eliminate duplication. What the heck is the largest char? I need to run this because I'm freaked out now. Okay, I guess. So it's like Q. And do capital values work? Guess not. Like why? Oh, because they're before, I guess. Can I put an emoji here? I cannot, because that's not a char, is it? Can I copy this? Okay, can I actually copy it? Okay. Oh, because chars in Rust they're not U8. Sorry, I'm dumb, right? This is UTF. Okay. So it's just the UTF encoding. Char in Rust. Yeah, it's a Unicode scalar value, not... has nothing to do with ASCII. All right. Interesting. So yes, the largest char, which I guess is the largest Unicode or something, probably, possibly. Definitely not production code. So running the code will, not this one, sorry. Not this one either. Generic data types. The parameterized function, okay, so then we just call it T. We have to put angled brackets. When we use a parameter, we have to declare a parameter name, short for type. So types are upper camel case. Okay, so my type with M and T capitals. When we use a parameter in body function, we have to declare the parameter name in the signature so that compiler knows. Similarly, we use a type parameter to define the generic. We place inside angle brackets. We've kind of seen this with Beck. So largest with a generic type is a list, a reference to a slice reference T, and it returns a reference to T. Okay, it's generic over some type T. This function has one parameter named list, which is a slice of values of type T. We'll return a reference to a value of the same type T. Why does the code not compile yet? Interesting. Let's see, can we figure this out? This looks suspiciously correct. Oh, because yes, very good. So this greater than is super ambiguous. What if I have a struct? What does it mean? For yeah, so it needs the partial order trait. Okay, so then the compiler tells me it's a T that has this trait. Good. So the syntax is I can also annotate the type, the generic type, I can annotate it with traits here. Interesting. Well, this is very ergonomic. The issue is that when largest takes a slice, the function cannot assume. It could be file. However, largest requires it can compare with. If T needs this, unlike languages like Java or all objects has the same core methods, there are no core methods in Rust or core traits. Without restrictions, the generic type T has no capabilities. It cannot be printed. Oh yeah, okay. So another good one is print. So let's see if I do this. I want to see something. It's gonna require a print trait. Plus, I was looking for the notation to specify it must implement two traits. So plus is the keyword here. Interesting. Pretty ergonomic. Except it does start to get like kind of big ass, I guess. And you do this. Not sure what the coding pattern is here. Something like this maybe. And then you go this. I guess you just go this. Maybe. Okay, we're starting to get into dangerous land. Maybe I do this then. Alright, this looks horrible, so I don't know how to write these. I'm curious what a formatter would say here. Also, is this supposed to be glued to it? Yes, it makes sense it's glued. I mean, they all work. Compiler doesn't care about spacing, apparently. Which we kind of knew. Alright, in the language, it's okay. We can also define structs. Okay, so a struct with two types T. And this one works because I don't do anything with it. Now, if I try to print it... Same story, I bet. Right? So if I do print line float.x, am I gonna get the compiler yelling? Oh, okay, well, I don't know Rust, I don't know print syntax, so that's a big problem. What about this? The compiler does not expect what I have here to have the display implemented. So let me do this then. So struct circle r f32, that's it. So what if my float is a point with two circles? Well, hang on, there's something more ergonomic here. It's one of these structs, right? Like a tuple struct. Do I have to put semicolon here? So what if I have a circle? I cannot print float x. Yeah, we have to put semicolon, duh. Aha, but the compiler does go through here. I guess it specializes every instance, not the generic point type in this case. Interesting. Quite interesting, because if I do integer x, I get away with it. If I do float x, I get a bit of help from the compiler, which is interesting. So it specializes through that. All right. We can also define structs to use generic type of parameters. Okay. The syntax we're using, so if I do a point, okay, I can't mix types, obviously. This is an obvious mistake. When we assign an integer, mismatch types. Oh, you can use multiple generics, so T and U. Okay, so the syntax is comma, semicolon for traits, plus for more traits. Good. Now this you can use merging but using more than a few makes your code hard to read, of course. If you're finding your need, you can indicate your code needs restructuring into smaller pieces. This is good to remember. As we did with structs, we can define enums to hold generic data types. Okay, so we know the famous option T, right? Which is sum T none. This, as you can see, the option T is generic, over time is variance, over time T and non-variant. Enums can use multiple result. We know result, we've seen it. Result enum is generic over two types. In method definition, so we can implement methods on struct as we then use generic types and definitions too. Impl T. So this goes. Let me try something. Why does it go in the impl and not on the function? Because I could do it in function definitions. Wait a second, something is sketch here. So what if I do, can I also do fnk? Return type of k? I forgot to annotate methods. I mean functions. Okay. Interesting. Oh my god, it's after the name. I don't know the syntax. Yeah. So it's the function x generic over k takes self and returns k. Aha, so the T here references the type. So yes, you need this because when I say the struct in the impl, so it's impl for generic over type T for a struct that's also generic for a type T. And then yes, I have to return a T here. Can't get away with this? No, I can't. I can do a T, but it's redundant, I'm guessing. Oh no, I can't even nest it. Okay, so there's some scoping shenaniganry happening here. Interesting. Huh. So I can't... Yeah, okay, so these things are scoped, which we discovered by ourselves. Pretty good. Here we define a method on type T that returns a reference. So a method named X on point T. Note that we have to declare T just after impl so that we can use T to specify our methods on type point T. By declaring T, Rust can identify that the type in the angle brackets in point is a generic type rather than a concrete type. I see, so it's point angular bracket T, where T is generic specified by impl angular bracket T. Otherwise, it could be a actual type T. No, it couldn't. Wait, what? Because this is generic syntax. I'm a bit confused. It's just binding them together so you can reuse T, right? We can also specify constraints on generic types when defining. We could, for example, point F32. Oh, so you can specialize here. So you can specialize for point F32, distance from origin. This code means the type will have a distance. Other instances of point T where T is not of type F32 will not have this method defined. This method measures how far a point and use mathematical variable perform, but you cannot simultaneously implement specific and oh shit, so I lock myself out of impl point T with distance from origin. You cannot okay, this sounds very important then. You cannot simultaneously implement specific and generic methods the same name. For example, if you're for all types T and the specific, then compiler will reject your program. Rust does not know which implementation to use, of course. So there's no priority system. Interesting. Oh, this is pretty bad. So Rust doesn't have default. It doesn't allow you to do blanket implementations and then specialize them for a certain type when T is specialized that type. But otherwise sort of... Wait, so how would one write a construct like this then? Pretty interesting to think about, I guess. But I don't know the answer. So you would write the generic T. I guess you would specialize the type itself. Maybe we'll discover more. Yeah, you cannot simultaneously implement specific. More generally, Rust does not have inheritance. Yep, that's exactly what I said. For specializing methods, my friend, object-oriented language. With one exception, default trait methods. Generic type parameters in a struct definition aren't always the same as generic type in a struct. Oh, what? So it's not x1, y1? Generic type in a struct definition aren't always the same as those that you use in the same struct method signature. Oh shit, so I can do this. Whoa, 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 whoa. What the heck is going on here? Damn. So I have a struct x1, which is generic over types x1, y1. Then for it, I implement the mix-up function, which takes a point, generic over two types. What the heck does this mix here? It returns x1 and y2? How is that possible? Oh, because it returns an other. Oh, it's another instance. Oh, so that's the annotation for self then. So I think this is under annotated because self would be point. Now it makes sense. Of course, this is why it's mixed up, right? Because it's self x1, y1. Yep, there we go. This is the right way to... I don't know why the heck they don't annotate this. Well, I guess this is considered over annotating in Rust. But it does make the mix-up effect clearer without me having to read the code. Yeah. I guess it's ugly practice though. Interesting. Yeah, so I could really have a point over, yep, strings. And I mixed it up. I now end with a hybrid point. Wow, this is pretty powerful actually. Whoa, this is a completely different beast basically. But it all works because point is generic over any two types. So then I can create hybrids. Out of 4 types, I can mix 2. Okay, this is what I was looking for. So it does make sense to annotate the inner ones, but with other things. So you get combinatorics or combinations of generics. Pretty interesting. Very good to know. What else is there here? In main, we define a point that has 932 for x with value 5. Yep, and f64 for y with blah, 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 blah. Okay, so the purpose of this administration on generic parameters are declared with inputs, not declared the method. Here, yep, we understand the mix-up example. Pretty good. Purpose is to demonstrate, okay, performance of code. You might be wondering whether there's a runtime cost. Doesn't seem like it, right? Yep, because it's all compiler. I don't understand why there would be a runtime cost. Rust accomplishes this by performing monomorphization at the compile time. Monomorphization is the process of turning generic code into specific code by filling in the concrete types. Okay, so that's the example we saw earlier. I was getting monomorphized. This process compiler does the opposite of the steps you used to create. The compiler looks at all the places where generic code is called and generates code for the concrete types. Okay, so it does have a compilation hit then, probably using too many generic types. But I'm impressed the compiler can track all of these. When Rust, it performs monomorphization. During that process, the compiler reads the values that have been used and sends them 2 kinds of options. It expands the... Okay, so it actually specializes all the types. Interesting. Yeah, the monomorphized version, it's as if you had typed these manually. What the heck is going on here? Okay. The generic option T is remove some compile. Okay. When the core runs. All right. Okay, so let's do a quick quiz. Imagine using a third party for inclusion implementation you don't know, but whose type signature is this. Generic over T, takes as input T, returns T. Then you call mystery like this. Assuming mystery, then the value of Y must be... What? What do you mean the value? Is that, did they mean the type here? I'm so confused, dude. What is this? Imagine using a third party for implementation you don't know, but whose type signature is this. I take as input a x of t and I return something of type t. So I can just do x plus 1 or x plus 2 or x plus 15. How am I supposed to know what? Assuming mystery uses no unsafe code? What am I missing here? Am I blind? All right, this is so annoying. What is happening here? So I can just take this and then you're telling me that I can do what? So I can do... Oh, I can't do +3 because not all types... Ah, this is so smart. Yes, the value must be 3. The only possible function that does this is x. Because I can't do anything to it. I can't do plus. Because strings, if this were a string, it doesn't have... Right, so let y mystery 3. This is not going to compile. Okay, all right. Very smart, because can't even add. Yeah, there's no concept of adding an integer, right? So yeah, the compiler forced, but x is valid syntax. Nothing else is valid though, because I can't even do like .clone, right, or .copy. Nada, because yep, so T, there's no guarantee that T implements copy. So then the only possible answer is 3, because X is a valid function. Good. Determine where the program will pass the compiler. If it passes, write the expected output of the program if it were executed. A classic. We know we like these in the Brown book. So print a slice generic over type T, and it takes as input a slice of a vector of type T's. For each element of type T in the slice, print. Yes, this does work because I32s implement the display trait. Okay, so I will go with does compile, and I'll say 1, 2, 3. Okay. If this were something else like a struct, this would still be fine, but it wouldn't compile because it would yell that the struct doesn't implement the display trait. In is fine because you can always do in. This is a slice type, right? So it always implements in, which is some sort, whatever that method is behind the scenes, right? So you can always do for x and v. Yes, but you can do this in this case. Determine whether the program will pass the compiler. If it passes, write the expected output, all right, of the program if it were executed. Same old, same old. Let's see what's happening here. Struct point, a generic point with 2 fields. Okay, so they're both generic over type T. Oh no, this doesn't work because I can't implement the same function for generic and specialized. So we're done here. Yeah, so it does not compile. Okay, so this, I'm overloading it. I wonder if there's a way to specify T except for I32. Now that would be something. Can you specify generics over types except a subset? In Rust, obviously. Negative typing, right? No, stable does not support negative trait bounds. Well, this is on trait though. I meant the types themselves. No. Yeah. So you can't do T not equal to string. Rust generics exclusively on traits, not type identities. Interesting. So you can't do. So yeah, this does not compile because you're overloading F. You're implementing it twice, right? Once for any type, T, generic, because it's here, not... If this were T and you had struct T, this would still be fine. Yeah, it does not compile. Why is the slice wrong? Oh, I got... Whoa. Damn, I got burned badly here. But I don't understand. Wasn't the deal that the compiler checks these? Well, this is not cool at all because we found earlier. Whoa. Wait. Not cool at all because earlier. Not too happy with this. I thought we discovered the case where isn't it monomorphized? Doesn't the compiler monomorphize this then? And it infers that I don't like this. I do not like this at all. What's the deal with monomorphizing then if it's not good for here? T doesn't implement standard format display. Oh, I know why. Because we're doing the print on the outside. Not inside the generic body. Okay, got you. Yeah, okay. So I didn't discover anything. All right. Yep, does not compile. My bad. Okay, traits. Generics and traits. It's pretty straightforward. Trait defines the functionality a particular type has and can share with other types. We can use traits to define shared behavior in abstract. We can use trait bounds to specify that a generic type can be any type that has a certain behavior. Traits are similar to a feature called interfaces in other languages, although it's some differences. All right, that's good to know, I guess. A type's behavior consists of the methods we can call on that type. Different types share the same behavior. We can call the same methods on all of them. Trait definitions are a way to group method signatures together to define a set of behaviors. For example, let's say we have multiple structs that hold various kinds and amounts of text. A news article that holds a news story filled in a particular location, and a social post that can have at most 280 characters. We want to make a media aggregator named aggregator that can display summaries of data, either in news article or social post. So I need to implement that trait for both the types. To do this, we need a summary from each type, and we'll request that summary by calling a summarize method on an instance. Oh, I see. So first I define a trait, which is a group of methods. Then I implement the trait or the methods? The trait, which means implementing the methods. Okay. I see. Oh, so a trait is a collection of functions, which is basically an interface. Duh, obviously, that's why it's called that. Okay, makes sense. That's good to know. I did not pick up on that at all so far. But it makes a lot of sense now. So nothing too exotic. Here we declare trait is the trait, pub trait. Why pub? We also declare that crates depending on this crate. Okay, sure, can make use of this trait too, as we'll see in a few examples. Inside the curly brackets, we declare the method signatures, describe behaviors, which in this case is a bunch of functions. And you have access to self, I guess, magically. After the method signature, instead of providing implementation, we use a semicolon. Oh, I see. So these are declarations. Each type implementing this trait must provide its custom behavior for the body of the method. The compiler will enforce that any type that has any type that has the summary trait will have the method defined with this signature exactly. In this case, this trait is not generic over types though, which is a bit weird. Yes, because you may need functions that are generics that take a second argument that could be an arbitrary type. And I'm gonna just magically guess that it's really easy to guess the syntax, right? So I'm just gonna put a T then. Yep. So then I can do other T, I'm betting. Okay, I can, yes. Okay, so I can make traits the whole, like a T that sort of sweeps over the whole interface. Or I can do this. Aha, but I cannot do this because it's there's a conflict. Yep, the name T. So we gotta think carefully. Promoting something to the whole trait means it really makes sense to have it in multiple places, right? Otherwise I can just genericize each of the method signatures. Interesting. This is really cool stuff. This is really where I want to get to, so I'm very happy with progress. Declare which after method signatures are providing. Okay, a trait can have multiple methods. The method are listed one per line, and each line ends in a semicolon. All right, implementing a trait on a type. Now that we define the desired signatures. So how do we implement function? I'm a bit confused. Before, what did we used to do in methods? Oh, I see. So structs, you import directly methods for a struct without a trait. So can I convert this to a trait then? So what's happening here? So I would say pub trait display, and it would have a function x which takes self and returns t. Ooh, I'm in trouble here. How do I do this? So what, I say an xt, or do I promote the t? And then what do? I impl display t for point t fn x self reference to t self.x. Nope. Yeah, so I'm in big trouble now because I don't know I don't understand the syntax here. Cannot find type T in this scope. All right, so we don't know how to implement traits for generic structs yet. Interesting corner case. Because the struct is already generic. So what, I can't define an interface for it? No, there must have a way, right? Because otherwise it's weak. All right. We'll learn. So then for a struct that doesn't have generics, it's pretty easy. Implement summary for news article, and then I implement the function. Then I implement the trait for another structure that also doesn't have generics. And that's it. It's really easy. Okay. Implementing a trait on a type is similar to a method. Similar but not quite, because we tried to do it but we failed. The difference is after impl we put the trait name, then we use the for, and then specify the name of the type that we're implementing. Within the impl block, we put the method signature, the trait definition. It's fine. Instead of adding a semicolon after each signature. Okay, so I just implemented the function. The library has implemented uses if the crate can call the trait on methods. Because it's pub. Post.summarize. This code prints one new post, horse ebooks. Of course, as you probably already know, people. Whatever. Other crates that depend on the aggregator crate can also bring the summary trait into scope. More restricting to note is that we can implement a trait on a type only if either the trait or the type or both are local to our crate. For example, we can implement standard library traits like display, custom like social post as part of our aggregated crate because it's type blah blah. We can also implement summary on Vec. But we can't implement external traits on external types. For example, we can't implement display trait within our aggregator crate. Display and Vec T are both defined in the standard library. Okay, so I need wraparound types. This restriction is probably called coherence, and more specifically the orphan rule, so named because the parent type is not present. This rule ensures that other people's code can't break your code, and vice versa. Without the rule, two crits could implement the same type for the same type, and Rust will know which implementation to use. Interesting. So a bit of sharp, I guess so we always, if we want to implement a trait for something, we need our own type, which kind of makes sense. Using default, sometimes use that default behavior for some of all the methods. Also, you can actually implement something in the trait. Oh, wow. Oh, wait, so for some of all the methods, wait, so Rust does have, then as we implement the trait on a particular type, we can keep or override. Wait, so Rust does have overrides. What the heck? Interesting. We specify a default string for the summarize instead of only defining the method signature. To use the default, we specify an empty impl block. I see. So I need to tell it like if use have this trait. Provided the default implementation specified the news article implements the summary trait. As a result, we can still call the summarize method like this. Creating a default implementation doesn't require to change anything about the implementation of summary. Yep, so we don't have to implement such post listing 1013. Okay. Default implementation can call other methods in the same trait. Oh, even if those methods don't have a default implementation. Interesting. In this way, a trait can provide a lot of useful functionality and require implementation to specify a small part of it. Very interesting. So, I mean, I guess, sure, this is a pass-through here, but it kind of makes sense. So it can be like an aggregator, right? We could define the summary to have summarize method. Okay. To use this version of summary, we need to define summarize author when we implement the trait on a type. After we define summarize author, we can call summarize on instances, and the default implementation will call definition that we're provided. Because when summarize, the summary trait has given us the behavior of the summarize method without requiring us to write any more code. Okay, so we have to design traits extremely carefully then. Yeah. Interesting. So if you could group types in a meaningful way, you could have meaningful default behaviors. Huh. Interesting. All right, let's do the quiz. This should be easy. Maybe not. Let's determine whether the program will pass the compiler. If it passes, write the expected output if it were executed. All right, our favorite type of quiz. So let's see what's happening here. We have a trait, which is not public, but it's fine, make noise. And it has a default make noise that prints silence. I think this so far so good. Okay, it doesn't return anything. We have two structs that are singletons, empty. We implement make noise for dog and we specialize, we override the default with bark, and we implement make noise for cat, and we let the default go. We own both data types, so no shenanigans here. We can derive traits, implement traits for them. I'm not seeing any issues here. I'm gonna go with does compile, and the dog will make the noise bark. The cat will make the noise silence. I think so. No trickery here, right? Because I have instance. Is it that I didn't make it public? Is it something dumb like it's not public? If it's that, it's kind of dumb. Maybe it is though. Oh shit. Did I need to have pub? Let's see. Ugh. No, it only says we also declared the trait as pub. So it doesn't say that. Oh, look, like impl, right? No, there's a... Yeah, something is fishy here. I'm gonna go with does compile. I don't think it's a pub thing. The following statements are about what kinds of trait implementations are permitted by Rust. Select all statements that are true. Each statement which is true. Who wrote this? Let's see. So, you can implement a local trait for a local type. Yes. You can implement a local trait for an external type. Nope. You can implement an external trait for a local type. Yes, you can only implement traits for local types, period. No, why? Oh, I can also implement a local trait. Oh. Oh, so I don't need wraparound types always. I can implement a local trait. Okay, so I misunderstood. You just can't mark it pub then. That's it. Okay, so you can implement a local trait on an external type. Using traits as parameters. Now that you know how to define and implement traits, we can explore how to use traits to define functions that accept many different types. Aha, so it's a type annotation, a reference to something that implements summary. Wow. We'll use, and then I have access to the interface in item. We'll use the summary to implement on news article social to notify. Yep, that calls the summarize, which is wow, this is very helpful in like resource management, which is exactly what I would like to write. Yeah, so it's gonna be very interesting. I'm really excited now. So yeah, because you want to manage resources and you just define traits. You group the resources, you define interfaces, and you can implement generics, right? That display them, that process them. Instead of a concrete type, we specify the input in the trait. Accept any type that implements the specified trait in the body of notify. We can call any methods on item that come from the summary trait, such as summarize. We can call notify and pass in any instance of a news article or social post. Code that calls the function with any other type. Yeah, because they don't implement summarize. Summary, not summarize. Trait bound syntax. The impl trait syntax works for straightforward cases, but is actually syntax sugar for a longer form. Those are trait bound. Okay, so, oh, I see. So we know this. We discovered this by ourselves. So it's T that has summary. I see. So this works not only for, yeah, yeah. And it's a reference to T. That's it. The impl trait. Oh, okay, so actually I like this better. Yeah, so it's generic over a type T that implements the summary trait, and then it's this longer form is equivalent to the example was where we replace trait bounds with the declaration of the generic type after a colon inside angle brackets. So then I can do something like, let's see. So I can implement function my print that takes as input, which is a reference to something that implements display. I guess you have to call this standard format display, Rust display trait. Yep, standard format display. Okay, and then we can say print line. This is my print, and then I can also do print line. I know I can do this now because it implements my print, right? So my print of 3. Oh, FMT, not format, sorry. FMT display. A reference to the value 3, whoopsie. Yep, there we go. So now, well, actually I can just, I don't need the impl then. I can just implement on something that implements on anything that, oh wait, so this works. It does, because the reference is also a type that implements the standard format display trait. Wow, pretty strong. So then I can do it on A. I can do it on, so this is a char. I can do it on a string slice. I can do it on a string from a string slice. And the possibilities are pretty much endless, right? I can define a struct and implement for it, and I can do it on it. All right, I think I get Rust now. Pretty good. Wow. Okay. So the impl trait works for server. The impl trait is convenient and makes for more concise code in simple cases, while the fuller trait bound can express more complexity. For example, we can have 2 parameters that implement summary. Doing so with the impl trait looks like this. Using impl trait. Okay, I guess this is longer, yeah. If you want to force both parameters at the same type. Oh, I see. Wait a second. This is more complicated now. Because then, otherwise I could have made T and K. And I could have put T and K if they have different types. Interesting. Yeah, definitely like this syntax more. The generic type T specified as the type of the item in item 2 parameters constrains the function as a concrete type of value passed an argument for it must be the same. Multiple training bounds with the plus syntax. Oh, okay. So we discovered this by ourselves too. Yep. So T plus. Summarize and use to format the item. Very good, very good, very good. Clearer trait bounds with where clauses. Even more. Oh, wow. Using too many training bounds has its downsides. Oh, this is the syntax I was looking for. Okay, okay, yeah. So instead of having the angled bracket sausage, you separate the types in the signature. Oh, wow, this is so nice. Finally, I understand Rust syntax. Holy shit. I cannot believe this. Whoa, wait a second. This is huge. Okay. So finally, we can read all the Rust docs. Oh my god. So finally we can read stuff like this. Well, this we can read, but like, where's the where? There we go. So pub fn from fn is generic over type f, returns the vector of type t, where, I guess this is not a trait, this is another type annotation inside where. Interesting. All right, so we need to discover more about the where, but yeah, so Oh no, wait, it is. No. Wait. Where F implements the trait fn mute, which gives you a type T. Interesting. So you can, oh my god, so the T here is this T. Good. Very good. So using too many triples, yep. So I can implement a function with two types, generic over two types. So I separate the types in the signature, and then I can specify what traits I'm expecting from each type in a nicely formatted list. The function signature is less cluttered. The function name, parameter list, and return type are close together, similar to a function without lots of trait bounds. Strongly agree. We can also use the impl trait syntax in the return position to return a value of some type that implements. Okay, so it's just the type annotation, right? So a function that returns summarizable returns any type that implements summary. I guess in this case it's valid at compile time because it's hard-coded social post. By using impl summary, we specify the return summarizable returns some type that implements the summary trait without naming the concrete type. In this case, return summarizable returns a social post, but the code calling this function doesn't need to know that. The ability to specify a return type only by the trait it implements is especially useful in the context of closure and iterators. Okay, we haven't got to that yet. Create types that only the compiler knows, or types that are very long to specify. Oh, interesting. The impl trait lets you concisely specify that a function returns some type that implements the iterator trait without needing to write out a very long type. However, you can only use impl trait if you're returning a single type. What? This code that returns either... Oh, I think this was fixed in the latest... Oh my god, wait a second. Rust latest borrow checker. I think there's been some big news that the new Rust borrow checker is here 5 days ago, and I think they have this. Maybe. Definitely have something on branches. Cause borrow checker from the borrow was through the entire function. No, it has to do with lifetimes though. Flow sensitive borrow check. Okay, of lifetimes. It's not this. So this is still a limitation of Rust. Why? Because the compiler, oh my god, so the compiler can't actually process the branches? Like, both of these implement summarizable. This code that returning either isn't allowed due to restriction about how the implement is implemented in the compiler. Yep, this is a pure limitation. Because for a human, this reads fine. And it seems easy enough to verify, but obviously I don't know anything about compilers. Returning either. Okay, using trait bounds to conditionally implement methods. Wow, more good stuff. Whoa, what is this? By using a trait bound with an impl block that uses generic type parameters, we can implement methods conditionally for types that implement the specified traits. For example, the type pair T always implements so. By using a trait bound with an impl block. Oh, yeah. So we discovered this by ourselves. So I can do impl T. Sure. The type here is implemented that returns this is pair T. Oh, yeah, wait, but these are methods though. This is not, yeah, it's a trait bound to condition implement method. So this is not a trait. It's just the trait notation. I think. Yes. Yeah, it's just trait bounds, right? For methods. So then I can implement T for this struct pair T. So it didn't answer my question though. How do I implement a trait for a struct that has a generic type? Because this is not a trait. These are just methods directly implemented. I think. That's how this reads to me, at least. Okay, so we can also conditionally implement a trait for any type that implements... What? We can also conditionally implement a trait for any type that implements another trait. Blanket implementations. For example, the standard library implements the toString type. Oh, I see. So you can... Okay, so this is pretty object-oriented. It smells like object-oriented, I guess. The standard library implements the toString trait on any type that implements the display trait. So then it looks like implement for any T that has display toString for T. Oh my God. Okay, the syntax is a bit brutal. So what is the regular trait syntax again? It's impl the trait for T, right? Yes. Okay, so it is the same syntax. It's just that you specify T display. Because the standard, we can call the toString method defined by a toString trait on any type that implements the display trait. For example, we can turn integers into a corresponding string value because integers implement display. Blanket implementations appear in documentation for the trait. Oh, blanket. Oh my God, I understand so many things now. We can actually read the Rust docs. This is pretty good. Traits and trait buttons as Rust code use generic type parameters to reduce duplication. But also specify to compiler that we want the generic type to have particular behavior. The compiler can then use the trait bound information to check that all the concrete types used with our code provide the correct behavior. Dynamically typed languages, we get an error at runtime. Rust moves their compile time, while addition we don't have to write code. Good, very good. Now this we got ace this one because we kind of blew the quizzes today. So determine whether the program passed the compiler. If it passes, write the expected output of the program if it were executed, our favorite type of question. Use standard format display trait. A function displayable that is generic over any type that implements display, and it takes an argument of that type. And it returns something. It returns any type that implements display. In this case, it returns T. Oh, yeah, which I guess we know from this constraint that it does have the display trait, so it is a valid. I mean, but I don't know if the compiler is this. So how am I supposed to know how strong the Rust compiler is? I guess just as a human, if I read this reads valid to me, right? Because T is coerced to implement display, and we need to return something that implements display, and then we return T of type T, which matches. Now the question is, does S, the string, don't tell me it's the mute thing here. What should have been mute imp display? Impl display? No, it can't be that. Come on, that would be dumb, right? No. So this is valid, right? So S is the type is string. String has display, so it compiles. And that's it. Push string, whatever it does, I don't. Oh, it's in place, so it's still S2. Yes, it does compile. Come on, it has to compile, right? Hello space world. Unless I'm missing something, come on. Because I'm not implementing anything. I'm not implementing anything for external types, like external traits for external types. Definitely not violating that one. Why would this not compile? Come on, it must, right? Is it the mutable thing? That's like what? I need to do mute impl display in the signature? No, that would be the dumbest thing ever. No. That's not how Rust works. Because the mute keyword modifier can modify the output of a function. I mean, it's a qualifier. It's an ad hoc qualifier. Yeah. All right, I'm going with yes. What? Okay, this one is interesting. Let's see. A different type of question. What is the smallest set of trait bounds on T needed to make this function type check, which I'm guessing means compile? So I have a function generic over a type T, which must have some traits. And then it takes as simple reference to T. So then I call clone and print. So I need clone and display, because they have nothing to do with each other. If I have clone, I'm not guaranteed to have display. If I have display, I'm not guaranteed to have clone, but display is not even the choice here. So the only possible implication would be that, okay, does anything that have clone have display? Doesn't sound, I don't know the Rust rules, but so I guess we can find that out, right? So Rust display trait. It's not a blanket for anything, right? So that's it. Yeah, it's a standalone type, and I'm guessing so is clone, obviously. Now, do I need debug? No, I do not need debug, because this is a plain print. It's not a debug print. Obviously, I can't have no bound, so it's going to clone display. What? Oh my god, we got the first one wrong. No, seriously? After all that time I spent double... Holy shit, this is wild. What doesn't compile here then? I gotta retry the quiz. Whoa. Something is horribly wrong here. So, we use display trait. Displayable is generic over any type that implements display. Takes as input T and returns a type that implements display. And it returns T, which implement... No, I don't get this one. Let's see it in the playground. This one seems very tricky, so I must be missing something. And I'm gonna regret it once I see what the answer is, but it's very frustrating. Damn it. I knew it. It's the... Wait. So I lose the type specialization here, and I can no longer call push string after this point. Ooh, this is so nasty though. The compiler doesn't know that I returned the same type. So this is actually not a string anymore. It's just an impl display. So I disqualified this as 2. This works because it has display. Okay, this I did not know. No. Wait. This is way more subtle than it looks like then, right? So I start with a string and I go through a function that yeah, this is a weak function because I was gonna say I go through a function that guarantees returns the same type as the input, but it is not true. The compiler doesn't know that anymore. The only thing the compiler knows is that this function returns something that implements display. So from this point onwards, S2 is not a string anymore. It is impl display. Yep, so this does not... So this should work. Oh, okay, I guess you could... Oh, interesting. You can't annotate like this. Huh, interesting. I didn't know that either. But yes, this is an impl display. So I cannot do string here. I cannot magically requalify this as a string. Nope, I can't. Mismatch types, yeah. Whoa, okay, does not compile. Because displayable returns impl display, then we only know that S2 is some type that implements display, even though it's a pure pass-through. But I guess for the compiler, this line of code is as hard as processing millions of lines of code, right? Because it doesn't track the types, at least not in that way. Okay, let's do some quizzes before we go to the, I think we're not going to do lifetime stake because those are brutal too, damn. Pretty brutal. Quizzes were bad today. All right, let's go back to options. So, option. This function returns how much ice cream there is left in the fridge. If it's before 22, I guess just the number 22, then 5 scoops are left. At 22, someone eats it all, so return none if hour of day is what? Really, this is it? So if hour of day is higher than 23, wait, what? This is so easy. So if hour of day is 23, none, else return some if it's before 20. Oh, I see. So if hour of day is less than 22, return sum of 5, and then sum 0 is the default branch. Sure, I guess. Very easy. I think. Yes, gotta be. Fix this test. How do you get the value contained in the option? Maybe ice cream is unwrap. That's it. I cannot return. Interesting. I don't understand. Why do I have type returns here? Because these are values, not expressions. What the heck is this? Now I get unneeded. What is this bullshit? What's going on here? So this one needs it? Oh. Oh, yes. Okay. So yes, this is an expression here. I guess I could have done this. Okay, so sum 0, sum 5. Maybe this is more ergonomic, actually. Yeah, okay. Is there a match I can write here? Because I don't like this at all. So match hour of day. Uh-oh. There is a match, but it's ugly. Nah, come on. So I guess we could fall in none in default. Sure. The problem is, how do I encode? I guess I can write hour of day less than 22. No, this doesn't work, right? So can I write? Well, this is an interesting question. So how do we write? Can you match on ranges in Rust? Oh my god, it's dot dot. Okay. That's what I want. Okay, so there is a more ergonomic way to write this, not this bullshit. Okay, so if I am higher than 23, it's none. If I am 22 to 20, no, just 22, 24. Yes, so 24 inclusive, it is sum 0. And if I am from 0 to 22, sum 5. All right, now this looks like more like Rust coding, right? Yeah. I think this is way more ergonomic, yeah, than doing like 50 if branches. Good. So, and it's also nicely arranged in chronological order. Good. Let's go to next one. I guess the unwrap here would panic, but sure. Yeah, so if I do a raw value here of 25, 26, this is a runtime panic, is it not? Yes. No. Well, I guess it is because of the panic. It's hidden in the test, but yeah. Okay, next test for this one. Uh-oh. The heck is going on here? Okay, so we have nothing. So we have some tests, I guess. Simple option. Let target rustlings. The optional target is sum target. Sum over a string slice. Make this an if-let. Oh my god, I forgot about the if-let statement. I forgot the syntax. So make this an if-let statement whose value is sum. Word. I don't understand what this means. I have no idea what this means, to be honest. What the heck do they want me to do? So if let statement whose value is sum. The problem is I really forgot everything about the if let statement. So if let oh, wait a second. So I need to if let unwrap so I need to unwrap the sum but I'm getting a runtime panic though. I guess this is gonna pass. I don't remember the if-let syntax. I do not remember the if-let syntax at all, and I hate it. Yeah, it's all the way in control flow or something. Yeah, concise control flow. So let config is sum. Match if let. Okay, so this is obviously horribly wrong. If let takes a pattern and an expression separated by an equal sign. This works the same way as a match, where the expression is given to the match and the pattern is its first arm. In this case, the pattern is sum max, and the max binds to the value inside the sum. We can then use max in the body in the same way we use. Okay, so this is unwrapping. Yes. So they want me to unwrap this, except I forgot the syntax completely, obviously. So then what they want me to do is if let sum word equals optional Yes, is optional target. So I unpack the optional target. Well, I unpack the word inside the optional target. And then I check if it's equal. If it does unpack, I guess if it's not none, then it asserts if the word is equal to her. How does that work though if it's not none? Oh, because it matches on the, it's only the match arm on some and not do nothing for, okay. Yes, this works. So it's basically matching optional target to some word. And if it is matched, hey, thanks for stopping by. Yeah, having a good day. Pretty good learning Rust. It's actually a very good day. It's the 5th or 6th, I think it's the 6th stream in the series, and we learned a lot today about like traits and everything. A lot of syntax stuff starts to make sense now. So we learned about generics and traits, but I'm getting killed by the Rustlings quiz because I'm still having older syntax problems. But yeah, feel free to lurk around or whatever you want to do if you have questions or anything. All right, so okay, we vaguely. All right, yeah, that's fine. Okay, so let's see. So this if let is basically we have an optional target which is an option. We know it's an option type, and then we're matching it to the left side of the if let, which is called a pattern, right? So then match optional target. If it is somewhere, then this is equivalent to the equals thing, like results. Otherwise, do nothing. Okay. All right. What the heck is while let though? This I completely forgot about while let. Seriously, like make this a. I've never seen. Make this a while let statement. Remember that vec pop adds another layer of option. So I have a range 10. I have a vec of options which starts from a none with a single element. I push some options to it. They're all sums, whatever, it doesn't matter. Okay, I decrement a cursor. That's what they want me to do here. I need to check while let because I completely forgot about what while let is. So this is not going to work. I don't want to blindly guess it. So did we even ever see? We never saw while let. I swear to God. Like, yeah, there's no way. Am I crazy? No, I'm not crazy. Like we're control flow. There's no while let. So, okay, fine. Maybe they want us to guess the syntax. Okay, so it's just unpacking, is it? So, let's guess the syntax, I guess. So, while cursor let. It has to be like this, right? So let some integer. So we're matching on optional integers. Pop. So we need to read the docs for vec pop. Whoa. What's happening here? Does pop really add another option? Oh, I know what they mean here. Yes. So we'll get like option or yes, it's option. It is option. So while cursor let, if I just do this is an option. Some. Oh, come on. How do I nest these? Seriously? You can do nested pattern matching in if let. while cursor, don't tell me it's if let. While cursor, if let, no, I don't understand. Let some integer, and then this one is if let, no, this is horrible. I need to see a while let example because it's destroying me. But let's do it this way. While let, let's not look at AI. Okay, let's look at the official docs. Similar to if let, while let can make awkward match this code. Yeah, I don't know about that. Can make awkward more tolerable because it really seems like we're on the verge of writing awkward code. So let mute optional sum 0. Repeatedly try. Okay, so match sum. Blah, blah. Okay, so it is while let. This reads. Okay, so this is what I don't know. So while let these structures optional into sum, evaluate else break. Okay, so first, okay, so the cursor is a dud here. So while let these structures, optional integers. Now here's the trick though. So optional integers dot pop while let some integer and then I type if let here. If let some integer. Oh, I guess no. So this is outer, right? Some integer is outer. This is how I would do it. But this looks horrendous. Like if this, there's no way it's this, right? Oh my God, it really is this. So I can do it nested. So while I do this and I'm inside, but then when does the while stop here though? Oh my God, it really is this. Holy shit. I can't believe I got this right without understanding like what? So, okay, so this means I destructure this. If I hit a sum, not a none in the outer, so something, then I enter this one and I destructure it again. The problem is, when does this loop stop? Oh, it stops when I hit the first none in pop. There we go. Which in this case I see. So this keeps going until this fails. There is, the cursor is a dud here. They just want to check that you did everything. Gotcha. So while let, okay. All right, pretty gruesome. While let, yeah, pretty gruesome. Next. This one's supposed to be even harder. What the heck is going on here? Let's see. We have a struct with the 2 integers. Derive debug. Okay. Let optional point. It's an option around the point. Pretty tame so far. Fix comparator by something to this match statement. What? Okay, match optional point. Sum p. This is a point p. That's it. So some point P, otherwise panic. This pattern has two fields. What? So we want what? This pattern has two fields, but the corresponding tuple variant it's not some point P, and then I can specialize it. I mean, it's specialized already, right? Because point has X and Y. Yikes. Big yikes. Oh, what is happening here? Some point. Like, do they want the full syntax here? Like, point X, Y? No. Oh my god, wait. It's P of point type. No, it's not. What the heck am I talking about? Oh, I hate this. So is it like point P? No. Is it not point P? No, it's not point P. So I can't do some P because it needs type annotation, right? Don't tell me. Is it like some... Is it the borrow? No, it's not the borrow because this is a struct. Partial occurs. Is it a reference to point that it wants? It's a reference P? Right, expected point, obviously. Okay, I need to look up the match syntax because I forgot the match syntax again, obviously. I don't remember how to annotate, let's see, match. Destructuring structures. But I don't want to do it like this, that's the thing. So match, wait a second. So I need a type annotator, right? I can't just do by adding something, it said. So match, if it's some P, I guess I have to type out the full qualifier, like point, what is it then? X, Y. But how does, no, how do I give a name to P? Oh, I see. It's, okay, so I just don't know the syntax. So it's P, which is a point with X, Y. I guess not. Still confused about the syntax here. Let's fix the compiler by something to this match statement. So it's obvious he wants me to type annotate this. Is there any match example here? There is no match example. Well, it says, sure, so some V. I need to see the advanced thing in matches because it's so goddamn annoying. If loop Where enums and pattern matching. The match control flow. What am I missing here? Because I'm going crazy. So, and it's not sum. The option T match pattern. Sum I. Sure. Matches are exhaustive. The problem is this is advanced syntax. So match on some struct. Pattern syntax. Okay, this is what I need. Chapter 19. Like, how am I supposed to know this? Patterns in matching. Yes. Like, am I supposed to... Oh my god, I hate this. So sum. Okay, matching multiple patterns. 1 or 2. This is easy. Ranges. Still doesn't tell me what I want to do. Destructuring. P. Let P is point. Point is P. Okay. Match P. Sum point. I can't believe it. Even this one doesn't tell me what it is. Nested structs and enums. Point. Structs and tuples. Let point. Ignoring values in a pattern. Parts of a value with nested. Sum. An unused variable starting by name. Blah, blah, blah. Remaining parts of a value. Point X. Okay. Match. When we compile this example. Dude, insane. Like, sum X. Okay, sure, but these are all scalars. Like, there's no sum match example on a struct. Okay, this is wild. So Rust match example on struct. On some struct. Sure, but I can't do point XY though, because I cannot do point XY here because he also wants to access P. So what, is it equal? Is it let P? There's no way, right? No. And is it P semicolon? Because I swear it's this. P that has XY in it. It's obviously not just, and it's not P that is a point. No. It's just some P and it doesn't work. The compiler says ref P. I've never seen ref in my life, I swear to God. Like, what is going on here? Yeah, I have not seen ref. Match some ref Rust. Ugh, this is really, did we ever see this? Like, I swear to God, it's like 20 hours of learning Rust and I have no idea what this is. Maybe it's somewhere here. Like ref. It is not. I guess you're supposed to use the hint. I mean, the compiler message is obvious, but ref annotates pattern bindings to make them borrow rather than move. It is not a part of the pattern as far as matching is concerned. It's not affect whether, only how it is matched. I see. So some n moves it. Yup. By default, match systems consume all they can, which is not to be a problem, and we don't really need to moving on. Using the ref keyword, the value is only borrowed, and it's not the ampersand symbol, which is insane. Okay. Oh, they have a section here. So ampersand versus ref. Ampersand knows that your parent expects a reference to an object. Hence, the ref indicates that you want a reference to an unpacked value. It is also not matched against foo ref foo. It's not matched against. Foo ref foo matches the same objects as foo foo. See the reference. Okay, identifier patterns. Interesting. All right, well, I don't know where I was supposed to pull this out of, but obviously I had no idea about this, so whatever. Sure. All right. Error handling. More unpacking now. Okay. A lot of quizzes here, though. Holy shit. I have a feeling this is going to destroy us. Well, me. Generics good. Result. Okay, we need to learn more. We need to review the result because we're going to get destroyed by this. So let me look at the result type. Result is a richer version of the option type that describes possible error instead of possible absence. Okay, pretty good. So it's a type. It's a generic type over T and E. Okay, an element of T was found. Error. An error was found with element T. By convention, the okay. Like option, result has many methods. Okay, which we can find in the docs. We don't need to memorize all of them. That's fine. Unwrap, for example, either yields the element T or panics. For case handling, there are many combinations between result and option. And working with regards to return result type. So it's pretty common. Okay, gotcha. Such as the parse method. It might not be possible to parse a string, so parse returns a result. Using result in main. The result can also be returned in the main function. Okay. Panicking in the previous example does not make for robust code. Oh my god. What the fuck is this, dude? We want to return the error to caller so we can decide what is the right way to respond. We first need to know what kind of error. To return the error type, we look to parse, which is implemented. This is a method on result? Oh, no, it's a method on string. As a result, the error type is specified parse int error. The straightforward match leads to code is overall more cumbersome. Right, so I can match this, which is a result, and if it's an OK with the first number, oh god, because I need two numbers. I guess it's, yeah, if either this loop could have been reversed, but yeah, horrible. Luckily, options map and then are also implemented for a result. So first number parse and then given first number, second number parse. Okay, I don't understand this syntax. It's a bit more complicated because I didn't get to closures yet or map functions. Okay. All right. Aliases for result. How about when we want to reuse a specific result type many times? Recall that Rustlings create aliases. Whoa, I feel like this is going... Okay, this is going way too advanced. Hang on. What's going on here? Alias at a module level, creating aliases can be particularly helpful. Errors found in a specific module often have the same error type. So single aliases are all results. This is usually an IO result. Define generic alias for a result when the error is past error. Okay, so it's a type generic over T. Oh, I see, which is either that T or a specific error. Okay, so it's just the result. I see. So you bind an error to it. Use the above alias to refer to a specific. So then you return this alias result because you know this parse will return parse int error. Here, the alias again allows us to save some space. Sure. Okay. Early returns. The previous example, we explicitly handled The error is using combinators. Another way to deal with this case now is to use a combination of match and error returns. That we can simply stop executing and return if one error occurs. So multiply. First number, second number. Result, I32 or parse int error. They forgot the alias here, but it's fine. Let the first number be the expression, which is a match on the parse. Oh, I see. This is a return arm here. Oh, yeah, because we directly, this is like a Python raise. Okay. So pretty Pythonic, right? Like raise the error immediately. Oh, okay. So this is Python raise. Yeah. So if, or try, except raise, basically. Okay. So raise the error on the outside. Explicit combinators. Introducing question mark. I've never seen this. Seriously? What the heck is question mark? Sometimes we just want the simplicity of unwrap without the possibility of a panic. Until now, unwrap has forced us to nest deeper. Upon finding an error, there are two valid actions to take: panic and return. Question mark is almost exactly equivalent to an unwrap, which returns instead of panicking. Oh, really? So parse, and if it's an error, return the error. Interesting. Before there was the same functionality with the try macro. Same thing. Okay. All right, let's see what the heck is going on with this quiz, because I have a bad feeling about all these error handling. This function refuses to generate text to be printed on a name tag if you pass it an empty string. It'd be nicer if it explained what the problem was instead of returning none. Thankfully, Rust has similar construct that can be used. Change the function signature to return result. Okay, so we need to return a result, which is the type on the valid path and the error. So I guess it's strings in both cases, which is fine, but the first one is valid. And if the name is empty, return a string from empty names aren't allowed. Else string from. Now, what does format return? Is it a string slice? Good question, right? Because we don't really know, so we gotta consult the docs. Oh my god, I don't know how to read macros though. That is a problem. What the heck does this return? Oh, creates a string. Oh, okay. So it's directly a string then. So it's just format. That's how I read it, at least. Wait. Oh no, I need to wrap this all. Wait a second. Wait. So this is result. How do I wrap this? Oh my god, it's OK and ERR. Sorry. I forgot. OK and error. But what did they want me to pass on the test? Hi, my name is. Empty names aren't allowed. Oh my god, it's the other way. It's error and OK. Sorry. Okay, good. Okay. It wasn't that hard. Just again, syntax is death. Because I don't know the Rust syntax that well, so it's gonna take a while to do all this stuff. Next. Oh my god, this is way more to read than the exercise probably. Say we're writing a game where you can buy items with tokens. All items cost 5 tokens. And with your purchase item, there's a processing fee of 1 token. Okay, so say game, one token. A player of the game will type in how many items they want to buy, and the total cost will calculate total cost. Since the player typing quantity, will get it as a string. Sure. They might have typed anything. Oh, I see. Not just numbers. Okay, so we need to convert. There are at least right now this function is handling their case. What we want to do is if we call the total cost on a string that is not a number, that function will return a parseInt error. In that case, we want to immediately return that error from our function and try not to multiply and add. Okay, so it's obviously the question mark, duh, because that immediately returns. Now, handle the error case as described above. Oh, that's it. It's just a question mark, is it not? Yes. Yep, there we go. That's yeah, because it immediately returns. Now, so what I can do is, the nasty way to do this is so I let this and I say if QTI how the heck do I check if it's an error? I don't even know how to do it the crude way now, because obviously I forgot the syntax. So I need a match though, that's the thing. I need an explicit match, right? So we do match QTI error return error parse I guess it's error of E return error of E. parseInt error. So what I can't. So if it's an OK of QTI, I can return this one, right? Oh, sorry, it's just OK. Sorry. Okay, so this works like this. Well, yeah, it is horrible, yeah. And sorry, why did this not work? Because I didn't unwrap it. Right. Okay, yeah, so I need to cover the arms. Okay. Okay, all right. Yeah, so this is, I mean, this can be even more gruesome. Let's see. What if I make the code even uglier, right? So return, unwrap, and do nothing. Yeah, this works, but it's horrendous code, right? Right, because I need to unwrap it, but then I know it's unwrappable without the panic, because I know it's not an error, but then obviously I destroyed the code. Yeah, this is not how you write Rust code. Even I can get that. Okay, all right. So yeah, of course, we can match on QTI. We can unpack the error and return it back and do anything. Okay, now obviously this is all junk, so you just need to... put the question mark here, and it works, right? Because this unpacks it, and it returns the same error back. This is exactly like the Python raise, so pretty clean. All right, next one. This program is trying to use a completed version of the total cost function from the previous. Okay, it's not working though. Why not? What should we do to fix it? Let's see. Okay, don't change this function. Sure. So this works now. Fix the compiler by changing the signature and body of the main function. So I'm returning a result here because of the question mark here. Oh boy. So I need to return a result between nothing and the parsing error. Okay, so this is one. What is wrong in the body? I have a mutable tokens 100, pretend user input 8, cost. I don't see what's wrong here. So cost has been unpacked now. Because this line survives. Does this compile? No, it doesn't compile. Oh shit. Oh, so I need to return something now, or what the heck do I have to do here? Like I need a dummy return? Like this? Oh, yes, it has to be an OK. Which I guess is like this, right? Yup. Okay, which I guess is just okay. Yeah. Yup, so I made a mistake, yup, because I cannot return just the empty tuple. I have to wrap it in the result enum, so it has to be okay type too. Damn it. Okay. Okay, next one. Damn, this syntax is killing me. So we have an enum, a custom enum, creation error with two possibilities, -0. We have a pass-through struct with a U64 field. We have a trait. No, for this struct, we implement the method new. This function should always, okay, so this function should return either, so this is a constructor function, right? What it either returns an instance of self or creation error, which is either negative or 0. Okay, so then I don't even need to read the test. I can guess what this does. So I'll match on value, right? And then if it's 0, we'll return error 0. How do we write negative? Ooh, if it's like what? Up to 0? I think it works like this, right? We'll return error negative. If it's everything else, we'll return, there we go, the actual thing. Let's see, this looks about right? So assuming this open-ended syntax works, which again, I don't know Rust, unfortunately, but let's assume this magically works. So this represents all negative numbers. And what they want? Yeah, so positive non-integer, okay. error creation error negative, error creation 0. I'm pretty sure this is what this does. Oh, yikes. So it's creation error 0. Creation error negative. Duh. Okay, there we go. We got this one. This one was... It was a bit easier, I would dare say. Next. It's a lot of these, but it's good syntactical practice, though. This exercise is an altered version of the errors 4. It uses some concept that we won't get to, like box and the from trait. Well, we already know box. It's not important to understand in detail, but you can read it as ahead if you like. For now, think of the box dynamic as I want anything that does question. Okay, sure. Ensure this particular use case for boxes where you want to own a value and you only care to type. Oh, I see. So it's impl. Yeah. I guess it uses the dyn keyword. Interesting. Not impl trait. Where trait is a trait that compiles for any value. If it returns, well, okay. For this exercise, that context is the potential errors which can be returned in the result. Jesus Christ, what do I need to do here? So add the correct return type, result. Okay, so we want the main to return either okay or a box of something that implements which trait. What can we use to describe both errors? Is there a trait which both errors implement? Beats me if I know. Implement format display for creation error. Implement error for creation error. So new returns a creation error. What are the both error? Oh my god, dude, this code is so bad though. Like, what is going on here? Is there a trait? Is it error? Oh man, this syntax is killing me. So I have a custom error here, which is called creation error, and it has two variants. Okay. I implement the display trait for my creation error. Then I implement error for creation error. And I have a constructor new that returns creation error. So then I need a box of things that have what? Is there a trait which both errors implement? Is it display? I'm pretty sure it's display then. Creation error needs to implement into a box. And it's not error either. Oh shit, I forgot to annotate this the right way, sorry. Result. Oh, it is error. It's as easy as that? It's not display? Nope, the trait debug is not implemented for... Oh, okay, so it is error. This doesn't seem that relevant to me. I don't know what the heck is going on here. Using catch-all error types like box. Yeah, I mean, yeah, obviously it works because it's like catch-all. Isn't recommended for library or course to make decisions based on the error. Yes, this also makes sense. Instead of printing it, here we define a custom error type. To make it possible for callers to decide what to do next when our function returns an error. Which one is the custom error type? This one, the parse POS non-zero error. Okay. A custom error type. Positive non-zero integer. Positive non-zero error. So we need to implement from parse int. Which returns self. So what error does parse int throw to us? Oh, parse int error, obviously. Okay. And what do we have to do here? We just pass it, self parse int error. Seems like it, because this thing is implemented for us. I guess it's just a wrapper type, so it doesn't do anything. Okay, so we fixed this. So now what else do we have to do? So change this to return appropriate error instead of panicking when parse returns an error. So instead of unwrapping, we do well, actually, I can just put the question mark here. Cannot infer the type of the parameter f. Yikes, dude. What is going on here? So what do they want me to do? Like, to which test do I fail? The parse error. Positive parse, not a number, needs to return an error. Parse integer, which we did. But wow, this is brutal. We need to... Should I do a match then? So I do a match. Hey, thanks for stopping by. Yeah, it's fun, but the syntax, again, it's giving me trouble. So I'm not too happy because it's like the 6th stream and I'm still having trouble with the syntax. So is it the trick here then? I think it is like that because I want to throw the parse immediately. I don't even know if this is valid syntax though. If this thing survives, then I can unwrap it. It's not. What the heck is this? So it's a string slice.parse. Okay, so I need to read the docs for string slice. But yeah, thanks for stopping by. I appreciate the view. Made a lot of progress today with generics and traits, but now I'm getting stuck in this error stuff. So what do I want to do? So rust string slice parse. Okay, I need the docs for the parse though, because I have no idea what that does and it's impossible for me to see. So it returns either, okay, so it returns the type that implements from string. It's a result, so it's either OK from string, or any type that implements from string, or from string error. Because parsing goes from type error. The parse one a few times, you'll see syntax affectionately known as the turbo fish. The heck is this? Using the turbo fish instead of annotating for. I did not know this, and obviously. Yeah, unwrap doesn't handle a pen. Well. Oh, so I have to look at unwrap. You're right. Oh, I'm reading this wrong. Yes. Wait a second. So then the parse gives me a result, but then what the heck does... Okay, so I just need to read result. Okay, so I just need to read unwrap then, which I'm guessing. Okay, so unwrap returns the container okay without consuming the self value. Because this function may panic, it's used during discourage. All right, so then we can do it like this. So then I can split the parse. Now this is a result, all right? So then I do, okay, now I know how to do it. It's easy, right? So I do match X. Wait. I can just do question mark then. Because this throws, it raises the error. Otherwise it unwraps it. Expected parse positive non-zero error found parse int error. This may be a mistake where I had to Why is this not... Oh, wait a second. So I need to return parse positive non-zero error, but this will throw the one from parse int, which is... Oh boy. So this one has to be return... So why is this the... So I don't understand. I am returning something in that enum. Expected parse positive found parse integer, but parse int error is... Oh no, it's not. So what do I need to throw here then? Holy shit, what is going on here, dude? Is it this not parse int? I guess not, yeah. So the enum is different here. Okay, hang on. Oh yeah, so I can't throw this. Okay, got you. Okay. So we do match X. All right. If we match on OK, something, we don't do anything. If we match on an error E, now I have the parse. So this is the parse int error. And I have to return from parse int error. Okay, I think this is it. From parse int from E. Yes, and I guess I do a return here. Well, hey, hang on. We can make this nicer, right? Because then I can do this in the OK branch. We just go here. Except this is S now, right? Because I unwrap S. I think this is it. All right, so this is not 64. It's a result, obviously. Expected result. Okay, I'm kind of almost. Oh, yes. I need to return an error. Ugh. So it has to be wrapped. But wait, this doesn't wrap in error? No, it doesn't. Okay. Holy shit. Okay. All right. Okay. And I guess, but there's another trickery here though, because this map error, I guess it returns. Oh yeah, this itself returns a result like this. Except it changes the error type to be this one, I guess, right? This is probably what this does. Okay, not the worst. I managed to get it by myself. So yeah, so map error is generic over F and O. Takes an operator O that is a function. Maps result T. Yeah, it changes the error type. Okay, gotcha. Yes. It changes the error type. Okay, not too bad. I've seen worse. Okay, finally we can move on to generics, which I have a feeling are going to be a lot easier now that we're past this silly syntax. Yeah, I mean, these are trivial now because I don't understand this ordering though, to be honest. Like, these errors are super generic over types. Now they want you to do like 2 basic exercises, sure. Vec T is generic over type T. In most cases, the compiler is able to infer T, pushing the value of the concrete type. The compiler needs some help with the type. Fix the compiler, but annotate the type of the vector. I mean, come on, this is like... some integer type created from U8 and I8? So what the heck is it then? What the heck is into? What am I pushing? Okay, well, I don't know, so we have to see what that is. So... Rust... Oh, is it a reference? A value to value considers the opposite of from. One should avoid implementing into and implement from instead. So it's a converter and... Oh, it pushes into whatever numbers is. So what the heck is going on here? So into trait for U8 Rust. What does this mean? Oh, it's into the type of the... Okay, yes. So it is into the type of whatever vec. So what? I can just put anything I want here? Like definitely I32 works for everything, right? Because it covers these guys and these guys. Okay, well, this is kind of stupid. Sure. This powerful wrapper provides the ability to store a positive integer value. Rewrite it using a generic, so it supports wrapping any type. All right, so it's a wrapper, provides the ability to store a positive integer value. Okay. Adapt the struct implementation be generic over the wrapped value. So we definitely want a wrapper. Okay, sure. So it's a wrapper T of T. Nice. And then I have to implement for wrapper T. Value T. That's it. Sorry, new is also generic over T. Yes. Oh, and the impl is also okay. I forgot the syntax, but yeah, obviously it's just okay. It's like this. I definitely forgot the syntax. So I implement generic T. Okay, well, this is kind of disappointing. Let's move on to traits because it was kind of short. All right, this one should be beefier. And then lifetimes we can stop because we don't know what those are yet. The trait append bar has only one function, which implements bar to any object, which appends bar to any object implementing this trait. Okay, so it's a trait which has one method, append bar self. Implement append bar for the type string. So this takes ownership. We gotta be a bit careful here. We just have to append bar to a string now. So I do append bar, has to respect the signature, self. And I just do self push str bar, and that's it. I don't remember, what does push string do in Rust? Does it give me a new thing or is it in place? Push str. Okay, so it's in place. So then I just do self. Yes, I think so. Oh, mutable self. Yeah. Oh, no. I'm not allowed to change the signature though. Oh, okay, so we have to do it the hard way then. New is self let. Mutable new is self. Do I have a clone for string or what do I have here? Copy, capacity, from. New. I do not have a clone. I do have a clone. Clone from. Oh, I do have a... Yeah, I do have a clone, right? Yeah. Self.clone. New. And new. Oh, yes, semicolon, because it's not Python. Okay, this works. Okay, next one. Same thing, append bar. Implement the trait for a vector of strings. should, oh, now it should push the string bar into the vector. Let's see if I remember the syntax. So impl append bar for vec of string, obviously. And I need to append bar self does vec have clone? Because I can't do it in place, can I? Where is vec clone? I'm assuming yes if the types have it, right? Yeah. Okay, so then I can do new self.clone. So let immutable new, and then we can just do new dot push string from bar and return the new. Now the semantics here are drastically different because I'm cloning data on the heap. So let's try this. This should work. Yes. Now I'm curious if can I do this in place to be more efficient if we don't do clone, because we're not insane, right? The thing is, can I magically type a mute here? And can I just do self push? This would be wild if it works. It does. Okay. So this is way more, I guess, yes, it is more elegant. Yes. Okay, so this is also the wrong here because, yeah, I just need mute self then. Because I take ownership anyways, right? So I drop the old data anyway, so I might as well do it like this. So I give ownership back now. I don't just create a copy on the heap. This seems wildly more efficient. I wish we learned about Rust profiling too. Okay, next. Looks pretty good. I'm happy with this. At least some success. Otherwise, the syntax is killing me still. Let's see. License. There's a trait called license to do. Add a default implementation for licensing info. Okay, so default implementation means we need to write something here so that implementers like the two structs below can share the default behavior without repeating the function. Okay, so it has to be something that works for an I32 and for a string. What? Okay, so then I have to just... I mean, come on, is it just like string from default license? That's it? I just return this string? Add default implementation so that implementers like two structs can share default behavior. Because I don't do anything with self in the default without repeating a function. The default license. So then license, some software can implement licensed. Other software can implement licensed. I'm not changing these lines. I don't even care what version number is. What did the test say? Some software, other software. Yeah, so it's okay. This is the dumbest thing ever. Like, it's just the same thing for everybody. Okay, so pretty easy. Let's see next one. Hopefully it's harder. Okay, sure. They did the two string way. So this is what I guess doesn't matter, right? So, okay. Fix the compiler but only change the... What is the compiler error? By only changing the signature of this function. Oh, I see. We have to populate this. So compare license type. Software 1, software 2. Oh. Some software? What? And other software? Because now the compiler knows they implement license, so they have licensing info. Aha, there's a trick here, because it has to, it's not. It's impl licensed, okay? So the only qualifier I need here is I need something that implements licensed. There's no order here. Yeah, I mean, I don't even know what they want there. Yes, because they didn't let me... Well, there was this field here. But yeah, you can't reach... Yeah, there's no way, right? Because this comes after. Yeah. Okay, now this one was a bit trickier because the qualifier type here is just implements licensed. There's no order between them. So this should be enough now because this qualifies it to call licensing info, and that's all you need. String comparison is good. We should be good. Yeah, exactly. I think here, yeah, at this point, yeah, for the... So, well, hang on. You know what? Let's see. Okay. So is there a way to... Yes, there is a way because you can make... No, you can't. You can make this generic over types. But I don't know how to... Can you tell the compiler has... No, that's not possible, right? Because it has to be a struct with a field. You can't qualify it like that, right? To the compiler. You can put a T here. But that doesn't tell it... I know you can do the colon, like implements traits, other traits. But is there a has... Nah, there's no way there is, right? Like, so there have to be two qualifiers. Is a struct and has a field. Actually, this is a good question. So is it possible in Rust generics to qualify like that? Rust generics qualify. You can say things, yes, things have, well, types have traits, right? That's what they learned, they taught me in the book. You can say types have traits, but can you qualify something as... No, you can't. Rust generics qualify something as struct. Yeah, Rust does not have a built-in is struct keyword because primitive types can also be held data containers, but you can enforce struct-like behaviors. T is automatic as the size. Often we're using the structs dynamic unit qualifier with the size at compile time. Interesting. Yeah, this is probably too advanced then. And then the it has field part becomes way more complicated. Yeah. All right, let's see the last one that they want. This one was easy too with impl licensed. Some trait. Okay, so we have a default implementation for some function which returns Boolean. All right, pretty clean so far. And we have another trait with another function default implementation. And we have some blind, okay, this empty structs, and they both implement both traits. So I need a qualifier that it has both interfaces, right? Some trait and other trait. And the qualifier is impl some trait. Is it plus? Impl other trait. Because that's it. That's the only thing I can do. I believe it is. I'm not sure about the plus. Wait, no. Plus doesn't work. Wait a second. Wait. Doesn't it? It's the, I need to drop the syntactical sugar. I know what's happening here. There's an advanced version of this. So it's item of type T, where T has the trait, some trait plus other trait. Okay, this works for sure. Actually, I like this better. I should have done it this other way. Yeah. So this reads cleaner for me, right? So it's generic over a type T that implements both interfaces and item is of that type. Yeah, there we go. Does impl plus work like how I think it does? But even if it does, it looks really ugly, to be honest. Plus impl other trait? No, it doesn't work. Oh, it does work. It's just plus. Oh, okay. It works like this. I still kind of don't like it. Maybe it's, yeah, whatever. Okay. All right. So it was T, some trait plus other trait. Not too bad. Let's see. What do we have here? Well, let me start looking at, okay, so we'll do the, oh no, there's a quiz. Okay, let's do the quiz. What's the last quiz? Oh yeah, this is gonna be tough. Wow, this is gonna destroy me. So this quiz tests generics and traits, I think. No, I thought it asked me to implement, okay, never mind. So an Imaginary Magical School has a new report card generation system written in Rust. Their system only supports creating report cards where the student's grades are represented numerically, floating point. However, the school also issues alphabetical grades and needs to be able to print both types, make necessary code changes in the report card and the trait implementation, which is the default, I guess. Oh no, it's a method, well, it's a trait implementation for the struct to support alphabetical report cards. Okay. So we have a grade and let's see. Well, we have a problem here. So what do the student's grade is numerically. The school issues print self string. Ooh, I need an enum here then, right? So hang on, this is a bit more complicated. So grade, she's F32 and string. So now grade is grade. Okay. So then to print, I mean, I can do this the cheap way because I can derive display. Can I? For the enum? And I don't need to adjust the impl block at all. Unless I'm missing something. Let me try it the cheap way then. I feel like this is a giant hack that I'm doing. I'm not supposed to do this though, right? So, if I only knew how to type the derive though. So I think it's derive display. This derive. Yeah, I think so. Yeah, I think I'm cheating a lot here. Yeah, okay. Yeah. Let me see if this works just out of curiosity. It doesn't because I don't know how to derive it though. Okay, let's table this because I kind of want to come back to it. So yes, the more generic one is I can just make a T, but then I also need to implement this. Wait a second, it's not a T. It's a T that has standard FMT display. And that's it. This is the fix. Wait, so I don't need to wait. Sorry, not like this, like this. So then I still don't need to do anything here because I qualified it myself unless the syntax doesn't work and I'm making stuff up. I can't use this in a struct. I mean, okay, fine. It's not idiomatic. It's like this then. So it's impl T but how do I qualify the T here? Damn, this is so, yeah, okay, so this quiz is destroying me a bit. Wait a second, wait. So the cheap way is to do this, right? To ask this to implement display. And this kind of solves everything. I don't even need the generic here. Does this work? Ah, no, now I actually need to not do the... Ah, no, so I do need to do the generic. Yeah, okay. Wait, is it not like this? It's the other way around. I think it is like this, right? T. Okay, so this works, yeah. Okay, so but the thing is there no other way? Okay, so now what if I do this? This should also work because it's a subset, right? So I only implement this trait for versions of report card that have this specific T that implements this. Okay, good. This is better. I think this is how it should be, right? You don't want to tie this to printing. Okay, this is definitely better. And I guess what I don't understand is that, so this is sufficient to tell the compiler that it links self, the T and the grade is, wait, this is so messed up. This actually works? How does the compiler know that this grade the type is also the T type? I guess because it's the only generic? Like, what if we do this? TU. Okay. So now what the heck do I do? Because I have two now. How does the compiler know to match which with which? It's not going to work, right? It still works? Oh, I'm so dumb because the report card links it here. Oh, okay. Wait. So this specializes. Yes. You are right. Yep. Yeah, I see it now. Yes, it is matched perfectly. Yep. So it's this type. Yeah. Okay. Gotcha. So then this can be called the PQ here, and it doesn't matter. It's still going to work because it means the first and second types in the generic struct. Okay, gotcha. Yeah. Yep. Okay. So it means the okay. Good. How the heck do I derive display? How do I derive a trait? How to derive a trait for all variants of an enum in Rust? Is this a thing? No, it's not a thing, probably, right? You must extract geomatics with now. Yeah. Derive directly on the enum? Really? Trait-based enum variants. No, this is something else. Interesting. So I can do the hacky thing then that I was... okay, so what if we undo this? Aha. I think you're right. Let's see. So what if I go back to string and I just put this to be grade, okay? And then we just do impl. This should be it. That's it. Like, it's embarrassingly simple, but it is hacky though. Let's see what's happening here. So can we tell? So derive. The trait is not implemented for grade. Mod test use super. Aha, because this is grade. So it's F32. And string slice, all right? Not string. Based on the test. That's what you mean, right? Just to be strict here. But oh no, wait, this doesn't work. Enum variants can be variant. Oh, they can't be a reference. Oh, I can't do them. I can't just reuse F30. Why do I need like wrapper? I need wrapper structs on them. Numerical F32 and alphabetical. Which is a string slice. I get no. It has to be string. Yeah. Informal strings traits implemented for grade. Is it that I have to derive standard FMT display? No, it's not. Can I find display in FMT? Interesting. It would be derived display, right? Or is that not a thing in Rust? Maybe that's the mistake I'm making. Derived display trait Rust. Oh, okay. So it's just okay. So hang on. I'm just making stuff up then. This is not a thing then, right? Never mind. Okay. Okay. All right. Wait a second. Wait. So then we can implement it. Okay. So then I can say implement standard FMT display for, yeah, for grade. So how would we implement this? What the heck does, wait, can I implement a trait for an enum? Uh-oh, this is new territory. That doesn't sound right. Right? I have to implement it for each of the underlying types. What am I doing here? Can you implement a trait for a Rust enum? Ah, it's a match. I should have known this. Yeah, it must be a match, right? So then, all right. So then, okay. The other problem is I have no idea what the display interface is. So, interface Rust. How do I implement it for a custom type? FMT. Oh my God, this is gonna test the results and everything. This is actually puts everything we did together pretty nice, except this is gonna be brutal. Hang on. So I have to write this function. Okay, there's no way I can do this. Like, I don't know what this is. Like, I have to see, maybe if I see the source code of, oh, I see. Okay. Oh, I remember this. Hang on. It's not, well, it's not that hard in the sense that I copied this, sure. Yeah, I have to copy this. There's no way I could ever make this up. So, okay, so then we go like this. And we say, so now what do I need to do with the grade? Well, I have self. So I can say match. So I have a reference to self. Let me see now. I gotta match myself, right? There's no other way. And if I match on grade numerical of grade, then I go, I guess I just write this grade. And then I do exactly the same thing on the other branch because there's nothing else. I mean, yes, because they both have this, both of these subtypes, my variants, they have this they have the display implemented. So this is going to flow down to them. This looks kind of janky, but also not the worst, right? So I think I got this right. So I'm, is the match right? Uh-oh, whoa, wait. What the heck is self? It's an instance of the enum. I think it looks okay too. Yeah, I'm a bit thrown off by the reference to self. What does it mean to receive a reference to an enum? This is a bit concerning. I guess it's just syntactical sugar. It doesn't do anything in Rust, right? Like reference to an... I don't even understand what that means. And I guess should I match the reference then? Let's see. All right, so then I got the report card with the grade. So that's it. Then format. It's going to flow down. It'll print. Ah, yes, I need the full qualifier for this. So standard formatting. Okay. Oh, now the tests don't work. Yes, because I cannot use... Okay, very good. Yes, so I'm forced to type annotate this. Okay, so I think it's all good. Yeah, pretty nice. Not the worst exercise. Alphabetical. Aha, string slice. So now we have two choices. I either do string from. Can I just do string slice here though? I don't think this works. It doesn't. Because I don't. Okay, so I need to learn about lifetimes, which I'm gonna learn exactly next. So until then, okay, we'll have to do. I guess we'll do two string because it's cheaper. Okay, so this works. Kind of gruesome, but also maybe not that gruesome. I don't know. To be honest, I kind of like this more than generics. It is stronger type annotated. It forces you to either it exactly answers the question, like, because otherwise it could be integers. I don't know, yeah, or something else, or it could be some spurious type that implements display, but the enum here forces you. Not too bad, not too bad at all. All right. Okay, now we go to the big one. So let's. Oh my God, lifetimes. Okay. I feel like this is going to be a huge. Maybe not, though. Maybe I'm overestimating it because if I went through generics. So let's go back to the C.S. Brown book. Okay, yeah, it's not. It can't be that hard. It's only a section. Come on. Okay, maybe it is hard. Never mind. If it's not permanent to solve, if you know for sure it's gonna be one, yeah, it's probably better than generics. Yep, I think I like that pattern more. Yeah, but this was a good exercise though. Yeah, and actually, hang on. If we want to really kill ourselves, there is one more thing I was thinking. Let's see. What was I thinking? No. It was quiz. No, this is enough. Yeah, I don't see what else we could do here. Numerical, alphabetical. What was it? I wanted to do something else, but it's fine. Oh, yeah. I guess there's no shorthand way here. Is there really no way to unify? These smell too suspicious here. Something is off here. Like, can I qualify it with grade any? No, this doesn't work, right? These two branches, they look very like the right hand side, the expression is identical. This is not a thing, right? It can't be. I wish I could go back. Let me see. So list C. It's not variant not. It doesn't work like how I think it does. Interesting. And I can't do underscore because I don't have grade. Yeah, I mean, it would be bad programming anyways. It would defeat the whole purpose, but it's just annoying that the two branches, they look very suspiciously similar. All right. Lifetimes. All right, lifetimes are another kind of generic that we've been using. Rather than ensuring that type has the behavior we want, lifetimes ensure that the references are valid as long. Oh my God, this is gonna be hard. One detail we didn't discuss in reference that every reference in Rust has a lifetime, which is, yes, we know it's the scope by default, I guess. Most of the time, lifetimes are implicit and inferred. We are only required to annotate types and multiple types, and similarly, we must annotate lifetimes when the lifetimes references could be related in a few different ways. Rust requires us to annotate the relation to the generic lifetime parameters to ensure that the actual references. Annotating lifetimes is not even a concept yet. This is going to feel unfamiliar. Although we're going to cover lifetimes in the entirety, we'll discuss common ways. Okay, so it's like the light version. Dangling references. The main aim of lifetimes is to prevent dangling references, which, if they are allowed to exist, would cause the program to reference data other than data it's intended to reference. Okay. So we have a let R and let X. Okay, so obviously the X goes out of scope, so the data gets dropped and something weird happens here, right? So what, I can make this live on the outside? Is that what they're trying to say here? The outer scope declares a variable named R with no initial value. And the inner scope declares a variable inside the inner scope set the value. The inner scope ends, and we attempt to print the value. This code won't compile because the value that R is referring to has gone out of scope, obviously. Borrowed value does not live long enough. Yep, sounds about right. The error message says variable borrowed is not long enough. The reason is that X will be out of scope. Okay. Because it's code, we say it lives longer. For us to allow this code to work, are we referencing? Yeah, so it's undefined behavior. How does Rust determine its code? It uses a borrow checker. I mean, we know this, right? What are we talking about here? Or the borrow checker has compares scopes to determine whether all borrows are valid. Listing 1070 shows the same code as listing 1070 with annotations. Right. Here we've annotated the lifetime of R. Okay, with apostrophe A, apostrophe B, sure. As you can see, the inner block is much smaller. At compile time, Rust compares the, okay. A listing fixes the code. Okay, so this one's active until the end of the program. I guess they're supposed to overlap here, sure. Now that you know where lifetimes are, where the references are, and how, so it's all about scope then by default. Generic will write the function that returns the longer of two string slices. The function will take the two string slices and return a single string slice. After we implement the longest function, the code then should print the longest string is. Okay, so I have two strings and they are alive here. I pass ownership into the function. Okay, so what's happening here? So longest. Note that we want the function to, oh no, it's string slices. Oh, okay, I know what's happening here. Yeah, I don't pass ownership. So I pass references. And it doesn't compile because the reference goes out of, I guess what would happen, you would, oh, I see. So you would return a reference and then it immediately goes out of scope. So then you return an invalid reference, right? Return type needs a generic lifetime because Rust can't tell whether the reference, oh no, it's not that. Oh, I see. It's only in conditional code, I guess. So if this code were simpler, it would know to keep it. But then because it doesn't know which one it is, because it's at runtime, it's obviously, you can't tell. And it's not smart enough to keep both of them alive because this expression could be arbitrary. So then everything gets dropped and then you just, yeah. Okay. Actually, we don't know either, so we don't, yeah, because if this is at runtime, so we can't tell what's gonna happen. Oh, thanks for the follow 8 minutes ago. I missed it. Sorry if you're still here. Appreciate it. The help text reveals, okay, when we're defining this function, we don't know the concrete values. So we don't know whether, okay, we also don't know the concrete lifetimes of the references. Why don't we know the concrete lifetimes? Because why? So we can look at the scopes. The bar checker, because it doesn't know how the lifetimes of X and Y relate. This is why. It doesn't know how the lifetimes of X and Y relate. Okay, so it can't parse expressions. Oh, I see. So yeah, okay. So this could have been something very complicated here and very complicated here. So yeah, it's not like it's doing static analysis on the code or like to infer what's happening with X and Y. Lifetime annotations don't change how long. Oh, interesting. I thought they do. Oh, it's just a bar. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. Oh, so you still have to make sure that, okay, so this is not going to fix anything that goes out of scope. It's just going to fix identifying who is who. I thought it was the first one. I thought it was going to fix everything, but I guess not. Okay, interesting. Lifetime annotation has a slightly unusual syntax. Apostrophe, lowercase and short, A, B, C, D. Most people use the name A. We place lifetime parameter after. Okay, so my God, I have to learn more syntax. Here are some examples. A reference to 932 without the lifetime parameter, blah, 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 blah. One lifetime, but it doesn't have much meaning. Let's examine and function signatures. To use lifetime annotations function, we need to declare the generic lifetime parameters inside angle brackets. So it's kind of like generics. I mean, it is generics. Okay, so we have a generic lifetime A and X, Y, and the output all have the same lifetime. So this guarantees to the compiler that the output is tied to both of them or lives as long. We want the signature to restore the following constraint. The return, it's an AND operation. The return reference will be valid as long as both of the parameters are valid. So it binds all inputs together and it binds the output to them. This relation between the lifetimes of parameters. We'll name the lifetime A. This code should compile. Oh man, this seems, what the heck is this though? How do I mean, I guess okay, I need to see an example for different lifetimes then. Because right now it seems like you just add the same thing to everything. Sure, it binds everything together. It tells the compiler, I'm gonna do things with these things. And they'll depend on them. Which you would think that's by default, but it's not, I guess. Interesting that this is not default behavior. The function takes two parameters, both of which are string slices that live at least as long as lifetime A. Like, why would the two parameters of a function not live the same lifetime? Is it because, I know why. Because I call an inner function that may consume them and destroy them on one of them only. Okay. It's still curious that this is not default behavior though. In practice, it means that the lifetime returned of the reference returned by the longest function is the same as the smaller. Oh, it's also the smaller is the same as the shorter, I guess, of the lifetimes of the values referred. So the same as the smaller. So it's telling the compiler you should not seek guarantees after either of them gets expired or gets dropped, I guess. Hey, thanks for stopping by on YouTube. The function, okay, remember when we specified the lifetime parameters in this function signature, we're not changing the lifetimes of any values passed in or returned. Rather, we're specifying that the borrow checker should reject any values that don't adhere to these constraints. Note that the longest function doesn't need to know exactly how long x1 will live, only that some scope can be substituted for a that will satisfy this signature. When annotating the function, annotations go into function signature, blah, 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 syntax, not in the function body, lifetime annotations, become part of the contract, much like whatever this thing here is. Having function signature contain lifetime means the analysis, the compilers can be, yeah, I kind of made, I can see why it should have been in the body. If there's a problem with the way a function is annotated, the compiler can port to part of our code and constraints. Instead, the Rust compiler made more inferences. The compiler might be able to point to use of our code many steps away. That's true also. When we pass concrete references to longest, the concrete lifetime that is substituted is the part of the scope of X that overlaps with the scope of Y. The generic will get the concrete lifetime. What the heck is a concrete lifetime though? Shit. That is equal to the smaller, because we've annotated the return reference will also be valid for the length of the smaller. Let's look at how the, so concrete lifetime means like at runtime when it gets dropped from the heap, like when the reference expires, right? Let's look at how the lifetime, or I guess the stack, it depends. Let's look at how the lifetime annotations restrict the longest function by passing in reference that have different concrete lifetimes. So, okay, so now I'm doing scope shenanigans. Oh my god. Okay, so string 1 is has a lifetime over everything. String 2 has a shorter lifetime. Then string 1 is valid, string 2. Run this code and you'll see that the borrow checker approves. It will compile and print. Okay, sure. Let's try an example that shows the lifetime of the reference and result must be smaller. Must be the smaller. We'll move the declaration of result outside the inner scope. Wait, so this doesn't do... Oh... Is this what I think it is? Hang on. Something is... I don't understand. This doesn't seem to do anything until now. I mean, yes, it's a nice annotation. But... Hang on. I think I know what's going on here. So... This won't compile. Is it that I now have to tell the compiler... But I can't. If I put a B here... Oh no, so it's not like I'm forcing it at runtime, right? Oh shit, it's like 2 lifetimes. Nope, yeah, I can't, because like the book says, it doesn't change anything at runtime. So what, then I need to put this, if I put this to B, then I'm not doing anything, because then this reference is too short then, right? Yep. So are they actually gonna fix it, or... No, I guess this is broken code. Is it? Maybe there's some trick. The error shows that for a result to be valid, string 2 would need to be valid. Rust, no, yeah, there's no. There's no fix here through lifetimes, because they said that they don't change anything, right? It's just annotation. Rust knows this because we annotated the type parameter. Whoops. Left this function. As humans, we can look at this code and see that string 1 is longer, and therefore result. Because string 1 is not gone out of scope. Oh no, but this is dynamic, of course, this is useless. However, the compiler can't see that reference. We told Rust that reference, okay. Try designing more experiments that vary the values. Yes, we already did this. Nice anticipation. Try designing that vary the values in the references and how the return reference is used. Many hypotheses about whether an experiment passed the borrow check before you compile. Okay, so what the heck do we do here then? Is there a way to compile this? Because no, I can't, because I dropped, if I move the result out, I don't have string tool. Yeah, I think the code is broken, right? Let's do the quiz. Oh, okay, this which kind of programming error is the lifetime supposed to prevent? Not the first one. Not the... It's the third one. Yes, easy. Okay, let's see this one. Oh my god, I just did this one though. What the heck? Ooh, this one is nasty. Whoa, wait a second. So, damn it, we should have played more. So I have 2 lifetimes exactly like I have here. And it's exactly the same function or whatever, it doesn't matter. But now at runtime, these have the same lifetime. But then am I telling the compiler the wrong thing here? Shit, I think it is, right? I think this doesn't compile. This is wrong. This is a wrong annotation. Like I told the compiler, the output lives as long as the first input, completely unrelated to how I gotta try this. So then this is easy because we just move this back. What I think is gonna happen is let's see. Yeah, it's wrong, right? Because I messed everything up. Yep, I cannot use 2 here. I can use 1. Okay, so then I don't understand. Yeah, this does not compile. I'm pretty sure it doesn't. Yes, okay. Okay, but when the heck are we supposed to use different lifetimes then? Relationships, okay. The way in which you need to specify depends on what your function is doing. For example, if we change the implementation of the longest function to always return the first parameter, I mean, yeah, sure, but now you have a guarantee that it returns. We wouldn't need to specify on lifetime. Okay, so these are not what I thought they are. This is just like basic annotation. It can't do miracles for you. Okay, it's not that hard then. I thought it was just like supposed to be a magical fix that lets you get around things, but it's not really, right? Interesting. Returning reference, the lifetime parameter needs to match. So you just need to match the semantics. If the reference does not refer, it must refer to a value created within this function. Oh yeah, but you can't have this in Rust, right? Because exactly, so you can't refer to things that you create in your own scope. Consider this attempted implementation, right? So you make a new string and you return a reference to it, you destroy the data, so this doesn't compile. The problem is that result are getting cleaned up, of course, where this has nothing to do with lifetimes. We're also trying to return a reference. There's no way we can specify lifetime parameters. Yep, so they don't do anything for you. Lifetime syntax is about connecting the lifetimes. Okay, so it's inputs to outputs. Once they're connected, Rust has, okay. Oh my God, it's in fields too. So far, the structs all hold old types. We can define structs to hold references. Oh, that's why I got that error. I see. But in that case, so so this is the first time we see structs with references. Interesting. But in that case, we need to add a lifetime annotation on every reference in the struct definition. I guess same for enums because we hit the R for enums. So I put the field. And again, this doesn't do anything. Like for structs, this actually doesn't do anything. It's just a mandatory. As with generic, we declared the name inside angle. This annotation means an instance can't outlive the reference it holds in its. This annotation means an instance can't outlive the reference it holds in its part field. The main function here creates an instance that holds a reference to the first sentence. The data in novel exists before. In addition, all doesn't go out to scope until, let's see, hang on, something is fishy here. What's happening here? So I do a novel. I mean, I don't even know how to break this. Then it's impossible to break, right? So the main data in novel exists before. Maybe if I take a consumer. No, but if I consume this and I drop it, I drop everything, including that reference. So yeah, I don't even understand what it means to like, how could the. Is there any way I can drop just the part? Like, is there a drop? No, there is no manual drop in Rust. Lifetime elision. You've learned that every reference has a lifetime and that you need to specify lifetime parameters or function or structs that use references. We had a function that compiled without, yeah. Oh yeah, because we've used this hundreds of times. So yeah, in early versions, this Rust code wouldn't have compiled because every reference needed. At that time, the function signature would have been written like this. Okay, so this is exactly what I mentioned earlier. Like, yeah, this seems to be default behavior. At least now, okay, so when it's one input and one output, it has to be. There's no other way. Like, you can't type A, B, because you're telling the compiler weird. I mean, you're telling the compiler, yeah, it's a reference to some other data, which implies it will get dropped. So that doesn't make sense. The Rust program is parameters into the piece of Rust history is relevant because it's possible a more deterministic parents will emerge. Yeah, you would hope so. The parents program into Rust analysis are called lifetime elision rules. These are rules programs for far. Consider if the elision rules don't provide full inference. If there is still ambiguity, the compiler won't guess what the lifetime. Instead of guessing, will give you an error. Lifetimes on function or method parameters are called input lifetimes, output. Oh my god, they're gonna tell us about all this. The compiler uses 3 rules to figure out lifetimes of references when there aren't explicit annotations. The first rule is that the compiler sends different lifetime to each input. Okay, so it cycles through lifetimes. A, B, C. Oh, even the structure itself has one. The second rule is that is there exactly one? Okay, so this makes sense. This is, yeah, this I would have guessed. It has to be like this. The third rule is that if there are multiple input lifetime, but one of them is self or mute self. Oh, interesting. Self gets special. The lifetime of self is assigned to all output. Method's much nicer. Let's pretend we're the compiler. We'll apply these rules to figure out lifetimes. So this one's easy, right? A, and then the second rule says the output gets the input. Another example. So it gets AB. Oh shit, then you don't know what to do here. Yeah, so the second rule The third rule doesn't apply either. After working, we still haven't figured out. This is why we get an error trying to compile. The compiler worked through the... Yeah, okay, so I understand. So it's as if you had typed this, which you locked yourself out of anything, well, depending on the function. So it's up to you to type the lifetimes. When we implement methods on a struct with lifetimes, we use the same syntax as that of generic type parameters. Okay, the dumb question I have is, are they going to teach us how to combine these? Okay, it's comma. Okay, so this is good to remember. In method signatures, the reference lifetime names for struct fields always need to be declared after. They use after. Okay. The method signatures inside the impl block reference might be tight. In addition, the lifetime elision rules often make it so that lifetime annotations are necessary. Let's look at some examples using the struct name. Important. First, we'll use a method named level whose only parameters are references. The lifetime parameter declaration after impl and its use are required, but because of the first elision rule, we're not allowed to. We're not required to. Okay, because yeah, self goes to the output. Oh, here self goes to the output. One special lifetime is static. Aha, can live for the entire duration of the program. All string literals. Really? Oh, I see, because it's stored directly in the program's binary, which is always available. Therefore, the lifetime of all string literals is static. Interesting. You might see suggestions that when first specifying, think about whether or not you actually have to live. So these are like globals, basically. An error message attempting to create a dangling reference. Who's to fix those? Yeah. So what do we need to do? Generic parameters, trait bounds, and lifetimes. So where the heck is the trait bound? Oh yeah, it's the where t display. I guess this is full Rust. This is it. There's nothing more, right? Maybe. Oh no, there's the closure and map functions too, which is even more complicated. But now it has an extra parameter named and of generic type t, blah 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 blah. Okay. I guess you can also associate lifetimes to references to generic types, probably. I'm surprised they don't do that. Let's do the quiz. If a reference have a lifetime static, oh. Well, this is vaguely worded. I guess I'll go with this one. I don't know. They said it lives in the binary, which I guess is the static region of memory. This one sounds too naive. Consider the following unannotated function signature. Yes, Rust will accept it because no, it won't accept it. Because what? No, it will accept it. No, because it's a single thing, right? So it's one-to-one mapping. Yeah. The reference must have the same lifetime as the input in this case. There's no other way, yeah. If it was a reference to a struct, that would have been a big problem. I think this is fine. And it has to be this. Consider the following unannotated signature. Yeah, now it's exactly this one. Yeah, so this one's not accepted because now you have two things here. And these don't make sense. You cannot know which one it is. All right, so we got the, what the heck is this, dude? I thought, what do you mean it's never deallocated? It's deallocated. When the program finishes executing, right? Or maybe not. I guess it's actually in memory, like in storage. I don't know what they mean there. We covered a lot, and I believe there's much more to learn. Chapter 18, Jesus Christ. Okay. Oh my God, there's a giant ownership quiz, though. This is gonna destroy us. So let's do the... Let's see how bad the lifetimes are here. Yeah, let's do this as a warm-up. Okay, it's only 3 exercises, but the ownership quiz is going to be brutal. So the Rust compiler needs to know how to check whether references are valid. Remember, references are borrows and non-owner. What? Okay, fix the compiler by updating the function signature. Okay, this is exactly from the book. Like, what the heck? So a lifetime... I think it's like this. Yeah, because it can live with either of them. Okay. Next one, so just copy pasting. How do I return? I think it's just you can just type like... That's a reference to I-32. But yeah, oh, you're talking about like, cause it clones data. Well, no, because you can have a function that takes 2 references. And then I guess it dereferences them and then returns a new reference. But yeah, there's probably some clone shenanigans there. All right, so don't change this function because it's correctly annotated. Fix the compiler by moving 1 line. Uh-oh, this is the experiment we wanted to do earlier. I think it's this. So the only way to do it is I'm gonna move this string. Now they all... So now... But it can't be because this code is still wrong, right? Like I point to drop data. No. It's this one. There we go. So now they have the same... Yeah, okay, this is the real fix. Yes, it is the real fix. It has to be, right? Yeah, it is. That doesn't work though. That's the thing. If I move the print inside, I lie to the compiler because I tell the compiler that the 2 string references have the same lifetime, but that's no longer true in this case because the first one has a longer lifetime than the second one, right? I guess this works too. Never mind. Why? Because the end of the program counts here. Yeah, so there are 2 fixes here. If I had something else though, let x equals 1. This should not work, right? No, it still works. I guess the compiler is smart enough to infer when they're done. Yeah, so there are 2 fixes to this one. Move the string inside or move the data outside. To me, this one seems way cleaner because all 3 of them have the same lifetime now. Yes, they do, because even in that scope takes 1 of them. But then when it returns, it's still there. Okay. Lifetimes are also needed when structs hold references. Fix the compilers about the struct. Oh, come on. It's just like what? Seriously, this is copy pasting. Like AA, because I can't put B there, right? There's no way it's not gonna let me compile. Although probably it will, because nothing consumes this function. Like, I'll bet you this works here too, right? Yeah, it works because nothing happens with this, so the compiler has nothing to check here. All right, well, this was that's it. Yes. Okay, we're not doing tests, but holy shit, there's ownership inventory 3, which is gonna be really rough, because do I remember anything about borrow checking? We'll find out. Oh boy. At least it's on generics and stuff that seems more familiar, because I looked at it today. Question 1, program 1 returns the nth largest element in a slice. Function generic over t that implements a form of total order. Holy shit. I guess it allows for comparisons and cloning. And I take a slice, a vector slice of type t and an n, and I return t. I call sort in place. Probably, it must be in place. And I take the nth, I take a reference to the nth element. Well, this is wrong because the reference part is wrong. So t is a reference, and I'm cloning a reference, which I don't even know if a reference has clone. But then I'm okay. So hang on, this is easy. The bug is that, but I don't know if a reference. Oh no, it does, because t implements clone. If t implements clone, does a reference of t also implement clone? If a type implements a trait, does a reference to it also implement that trait? Well, regardless of what the answer to that is, it's none of the variants, because these are way more brutal. So, cannot move out of shared reference for clone. Shit. Cannot move out of shared reference expression. No, this is wrong. The lifetime of t must outlive. Yeah, there's no, it's only dot. Cannot borrow lms as mutable for sort. These all are different classes. Like, this is insane. Like, these are all errors. Like, I even forgot about the mutability if it's in place. Which, now that I see this, sounds like really suspicious. So maybe the clone is a dud, like it just works. Cannot move out of shared reference in expression. Oh, this doesn't make any sense. The lifetime of t. I don't know, it's a clone. It has nothing to do with that, so it's not. It's okay, so we know it's not the third one. Okay. Oh, I don't think it's the first one either. This one sounds like gibberish. Cannot move out of shared reference for clone. Clone doesn't need a move, right? So it doesn't make any sense. I'm going with the borrow one. Because of the sort. Yeah, it needs mutable self. I think it's that easy, to be honest. Like, what the heck is even going on here? Okay, we're going with this one. Okay, we got it. Oh my god. Okay. Assumed, oh my god, now they come with these questions. Assume that the compiler did not reject this function, which would pass the so let's say, I guess, if this were sortable, possibly cause undefined behavior. Oh, I see. So this is out of bounds indexing though. So what happens here, yeah, this is out of bounds indexing, right? Because I take the 10th element in an array of 5, which I guess what, runtime, no, that's a panic though, it's not undefined behavior. What? Okay, we're going with this one because it's out of bounds. Then I have a vector and I take a reference. Aha, this one is. So I take a reference to 0, then I change the vector in place. Well, that's pretty bad, right? But is it undefined behavior? No language has explicit label about whether a variable is in heap or stack. Yeah. Is that, I'm not familiar with the difference between dot and arrow though. Is that what it is in C? Or what, are you talking about like function pointers, or is it like for structs to access? Isn't it like to call a method, or what is that used for? Okay, so which one of these is UB? Damn, this is brutal though. Jesus Christ, this quiz, these are destroying me. So, definitely out of bounds. Now, this one will swap the vector from out under you. Out from, but, out from, but is it undefined behavior? I think so, because it may get reallocated on the heap. Let's go with that one. Although I don't remember. I know the vec, if it grows, it can get reallocated. I guess when you sort in place, we'll have to assume, yes, it can. This one, not. This one seems benign. Like, I do the thing and I print. Because nothing gets dropped, so the data is still there. Even though it was changed in place, it's fine. All right. Now we gotta fix this bullshit. Oh, of the following fixes, which one best satisfies criteria? The fix function passes the compiler, the fix preserves the intention, and does not introduce unnecessary inefficiencies. I can get a mutable to vector, and I can sort it. I can drop the clone completely and make this mutable. Why would I do remove? No, this is bad because I'm dropping the vector. What the heck is this? What is this? This is really bad. No, I need to pass reference, not vec. Mutable reference. Same thing here, like I can convert to a vec, but that seems wildly inefficient. Again, here I make a vec manually, then I sort. I'm gonna go with this one, dude. Like, what is this bullshit? Like, I really think it's as easy as they just forgot. Oh yeah, so clone reference self returns self. I think it's this one. All right. Another 3 of these and that's it. Another one. If you tried to compile this program, which of the following best describes the error you would get? Structure, test result. It has a vector of scores of integers. A curve, which is an option. So some or none. We have an interface. Oh no, for test result, we implement the following methods. Get curve. This one looks pretty correct, to be honest. Like, what the heck? Okay. And apply curve. Usable self. If let. So I tried to unpack get curve into curve, which is a U size. I guess a reference to a U size. Oh, right, because self curve returns a reference to, okay, so then a reference to the option unpacks into a reference to the thing under. For scores, iter mute. I can't tell why this doesn't build. So I have to read the options. In get curve, cannot return a reference to a local variable. No, this is wrong. Is it? Yes, it is wrong. In apply curve, cannot borrow self as immutable. I think it is this. Let's see. So if there's a for loop trickery here. Shit. Yes, it's this one. In this scope. No, but these are ordered properly though, right? So first I take a... It has to be the third one. It's not the fourth one, because that's dumb. I have both an immutable and a mutable reference, but are they at the same time? I don't think so, because the immutable one gets resolved first. And then if I enter that branch based on it, then I mutate the array in place. But what's the problem? I can't do that. So then is it 1 and get curve cannot return a reference to a local variable? What the heck is a local variable? That's not true, right? There are no local variables. It has to be the borrow checker. Or is it the fourth one? In apply curve, the value that's dereferenced from score cannot be mutated. I don't think that's true. All right, let's try it. Okay, I got this. We got this one right too. Oh my god, so it was the double borrow. The problem is I can't see why. Like, isn't this code ordered correctly? Because first I unpack this and then I'm done with it. I never use this reference. Oh my god, I use it here. I'm so fucking dumb. Okay, I got it right by accident, but yes. So the result of this reference is used while the, yeah, so okay, so I'm trying to use, okay, all right, good, we got it right. It was intuition, but yeah, it had, well, we got it right by exclusion, let's put it that way. I don't understand why it was, why we didn't understand, okay. Yeah, so it's obvious this curve ties everything together, right? So yeah, it's not gonna work. Good, because compiler doesn't know what I could do with this. Oh shit. Now we have to find out. Oh, right. I have to also understand what this does, which is gruesome by itself. What the heck does this do? So this one's easy. It just adds something to all scores. Okay. So what do we need to do here? So scores vec 20, 50, 30, 10. X. A reference to score 0, apply which changes it in place, and I print X. Smells like undefined behavior. This one is fine. It just changes it in place. This one's also fine. It's got to be this one because I'm trying to print X after. Does the data get dropped? No, it doesn't get dropped. That's the thing. But yeah, this can get reallocated. So, wait a second. No, it doesn't. Okay. All right. I think this is the trick one. I feel like none of these are UB. It's gotta be, right? These are all well tamed because apply curve doesn't do anything. It doesn't allocate data. It doesn't, it only changes the array directly on the heap in place. So it guarantees the same layout. Well, if the program would compile. This one is benign too. Yeah, so none of these are wrong. Unless I'm missing something. No, I don't think so, because I get a reference. And then I print it. The data has changed, but it's still there. It's not UB, it's just a different value. This one is benign. Nothing happens here. This one is also benign. All right, we're going with none. And now finally the fix. Which one passes the Rust compiler, preserves the intention. So the intention is to just add a value to an array. It's pretty simple intention. You would think we can solve this. And does not introduce unnecessary inefficiencies. I have no idea how to quantify this. It always annoys me. Like, okay. Okay, so this one decouples. I like this one already because it takes a snapshot. Am I hallucinating? What the heck is as ref? Maybe it's not this one. I mean, self curve is super clean, but I just don't need the... Oh, I think it's this one then. So I just unpack the option directly. And I'm done. No more borrow checking. Iter doesn't make any sense. It doesn't solve anything. Oh, it's immutable. No, but it doesn't work. No. Clone has inefficiency. I have no idea what asref does. Okay, so maybe I can read about Rust asref. That's the last thing I can do because I've never seen that. A cheap reference to reference. If I knew what that was, it would help, but it doesn't really. It has the same thing as borrow. No, this seems like it wouldn't solve anything. Like what? It's another borrow? Auto dereferences the inner types zeros, none to destroy reasons. No, this is for something else. I'm going with this one, right? Because we just look at, I mean, it is kind of dumb because we're ignoring the get curve. It's either this one or the as ref thing. Cloning is inefficient. This one doesn't fix it. I'm going with this one. 4 out of 6, not bad. Pretty good. Like, this was a tough one. Pretty good. Got this right. Bullshit. I hate these middle ones. Like, it's always so hard to guess. Oh, and we got this wrong. Oh, we got all of these right. Oh my god, we aced this one. Nice. Pretty good. Okay, what the heck happened here, though? What happened with this? So, yeah, this one I don't care about. The one that asks you to imagine. It was also a trick question. None. How come this is not out of... Because it's a panic. Okay, so this is not UB, it's panic. This one, I swear to God, doesn't the vector reallocate? I guess not. Sorting is in place, right? So sorting is truly in place in Rust. Oh, yeah, the sort is... No. I guess it is in place. So yeah, no memory. Okay, so then it was the same progression. Okay, the fix I got wrong though. So this program is technically memory safe, slice source capable of moving, not freeing them. For instance, blah, 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 blah. Okay. Yeah, it's a panic. I messed this up. I knew it was a panic. A function like findEnt is clearly intended to be a read-only function. And I guess because I made this mutable, I got penalized for that. Okay, so it's like the giant ass solution that makes a copy from scratch, sorts it, then takes the element. Okay, sure, whatever. Okay, not too bad. Not too bad. We did pretty good on the quiz. I think I'm gonna call it. Thanks everyone for sticking around. Thanks for sticking through the journey. I feel like today was a huge day. Yeah, earlier in the stream, I don't know, not many people were here, but I had to write like a full... Oh yeah, there was a very hard quiz in one of these. I don't remember which one it was, but I remember I had to write a full program, basically. Which was kind of wild. I wish I could find what I did. It must have been options. No. Quiz 2? Yes. So actually in quiz 2... we had to write this whole function transformer that works on a vec and returns a vec. So there was nothing here. Like it was just pub transformer. Complete the function. And then I had to write all this and I somehow got it right in the first try because it works on a vec to vec. So then you have to create a vec, and then I wrote a mini function pub transform that takes a tuple as input, matches on it. You have to pattern match the tuple. You have to return a string on the right side. Somehow I managed to get this right in the first try, which was pretty wild, just using the docs. So that was big progress. At least we understand. But again, no borrow checking issues, right? So this was straightforward. Functional Rust. Then we got into a lot more trouble though with the error handling, which I kind of lost it a bit. Generics were not that hard. Generics were very easy. Traits were not that hard. Yeah, I think overall it was good. It's a big chapter. I'm gonna have to practice this again next time. The thing is, I feel comfortable. I think we can start writing a Rust program next time. We'll do some basic type of resource management game. or the back end for a game, just the core functional logic or something. I think it should be pretty interesting. I really like the traits. Like, traits are insane. Like, I understand a lot more now. Yeah, like, traits are interfaces for types. The default implementation, the blanket implementation or the default implementation seems very strong. Generics, so pretty good. I'm pretty happy. We can start writing some real Rust hopefully soon. So yeah, thanks for sticking around. We'll see you next time, next week, probably Saturday evening, same time. Thanks for all the follows, and have a good night.